Okay, so advent of code, day one, trebuchet. Yeah, okay. So, trebuchet. Something is wrong with global snow production, and you've been selected to take a look. The elves have even given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th, right? Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So as always, nothing surprising this year. You try to ask why they can't just use a weather machine, not powerful enough, and where they've been sending you, the sky, and why your map mostly looks blank. You sure ask a lot of questions. And hang on, did you just say the sky? Of course, where do you think snow comes from? When you realize that the elves are already loading you into a trebuchet, oh, please hold still, we need to strap you in. As they're making the final adjustments, they discover that the calibration document, your puzzle input, has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. The newly improved calibration document consists of lines of text, each line originally contained in a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. For example, in this example, the calibration values are 12, 38, 15, and 77. Adding these together produces 142. Okay, consider the entire calibration document. What's the sum of our calibration values? Okay. Hi everyone. Hi Lynn. Okay, cool. So I have looked at the description before, and yeah, wait, let me just switch back to this code. Okay, so hello. I've I already have a plan because like part 1 is relatively easy this time. I have heard that part 2 is apparently gonna be tricky, so let's see about that. Right, but I mean it's pretty straightforward, right? We can just iterate through every character by character, find the first number we find, and also find the last one per line, and then just add them together and whatever. Part 2 was a pain, huh? Okay. That's I'm okay. I'm a little scared, but yeah, we'll see. I mean, day 1 is gonna be comparatively easy, right? Right? Well, we'll see. Right. So we're doing this in assembly, and I have not set this up correctly. Right. So I haven't written any assembly since I think last year's Advent of Code, probably. So yeah, I just looked up what the header thing here is. It is uppercase start? No, it's not. Okay, great start. Right. So first things first, we're gonna need to be able to read input anyway. Like the edge case for part 2. I shot myself. Insert in something else to sample. Okay. Okay, that's gonna be interesting. Right. So we're gonna need to do. First of all, we're gonna need to be able to read the input at all. So I guess we need like a read char function, more or less. And we have 2 options basically. We could either read, like do 1 syscall per character, which is kind of slow, or we could do like a proper buffered reader. I think I'm gonna do proper buffered reader just because why not? How do you declare constants in assembly? Data, right. I know x86, of course, I do. Okay, so I guess we're just gonna have an input buffer. That's how do you do byte arrays? God, I haven't done this in so long. DQ. no wait, that's times db0, right? Yeah. Okay, so let's do 1496, because why not? Bytes initialized to 0. Okay, and we have a input buffer size. That's a DQ, so a quad word, so 64-bit integer. That's going to be 0 for now. Okay, so God, I genuinely haven't done this in forever. I'm gonna struggle so much. Right. I'm looking at what I did last year right now, because that makes things easier. I guess that's actually going to be size, and let's use R15 for the buffer size, because why not? Yeah. Right. Or buffer fill size, whatever thingy. This should be the capacity then. Okay, so first things first, we need to compare R15, so our buffer size with the buffer capacity, and right, so we need to check if we need to refill, and otherwise we can just read one character from the buffer. So it's a jump if it's less than, no jump, well, okay, let's do, yeah, if it's less than the input buffer capacity, we can just, no, if it's greater or equal, we're gonna need to refill. No, that's the other way, because then I can skip like one jump. That's gonna make things a little easier. So I guess we need to do like a skip refill label here. Yeah, and let's worry about that after we do the interesting bit. Or after we do the easy bit, actually. Right, so now I guess we just move to Ix. How do you do offset things? Wait, I guess it's just input buffer plus R15, I think. And then inc R15. There you go. Oh, okay. That's interesting. I'm gonna check my OBS. I have no idea what's wrong. Let me just switch screens maybe. Is that bad? Is it working now? If I type something. Yeah, okay, perfect. No idea what that was. I guess it's just OBS being OBS. Cool, awesome. Right. So, right, if we skip the refill, is that correct? We do the input buffer and we use the offset into it. Yeah, right. We do a length buffer size. No, wait, it's not. No. Wait, I'm an idiot. That's not what we're gonna do. No. R15 is the buffer index, I guess. And we don't know if we've read 1496 characters. So we're just gonna override the capacity, I guess. Yeah, that's fine. But it's gonna be 0 initially. Right, and if we do a refill, I'm going to look up how to do read this class. Just pull it up. Right, so read is 0 into, I think it's RSI. Okay, actually, before we do all this, let me just see if this even compiles. Ah, nice. That's what I did last year. Nice to see that I haven't upgraded my my setup since last year apparently. And I still have my fish history. Perfect. Segmentation fault. Nice. But yeah, that's fine. It's compiled and we have start, and I guess we can just return 0 now. I have no idea what exit is. Exit is 60, right? And the first argument is, I don't remember, x86 calling conventions. Yeah, RDI, right. So it's RDI is 0, and I guess just describe, does it? Nope, that's not it. This exit take. Why is that not working? Uh-oh. Already messing up, I guess. Yeah, that did not work. What did I... What? Okay, I have no idea where OBS is getting confused. I'm just gonna switch back. Yeah, now it's working. Okay, I don't know, I guess if I switch screens, that OBS gets confused or something. Yeah. OBS just being OBS, I guess. Right. Okay, I still have no idea what's wrong here. Wait, 60s? Exit. Oh god. Told you I haven't written assembly in forever. Let's look at a Hello World example. Hello World in Linux x86 assembly, that's good. What? That's exactly what I'm doing. What? Move I. Oh, AX. Oh, not SI. What am I doing? Okay. Yeah, perfect. Okay. So that's how this guys work. Good thing you remembered that. Right, so let's move IX 0. Hello, Fontus. Type level assembly hello. Yeah, right. Right, so 0. What other arguments does read take? It takes a file descriptor, right? That's, wait, standard in as 1, no, 0, right? I think so? Yeah, probably. And a buffer and a length. When it's an assembly. So that's di, it's gonna be 0. It's gonna be standard in. And then SI is going to be our input buffer. And we try to read as much as we can, so IDX is going to be input buffer capacity. Did my screen look up again? Yeah, okay. Right, so that should read into our buffer, and Oh no, not input buffer capacity, but I guess, yeah, no, 1496. And we should also wait, it returns how much it has read, right? That's how read works. Right? Yeah, probably. So that's gonna refill our buffer, and then we can just read like we normally would. No, not IX into. No, wait, what? Oh, and we need to reset the buffer index. So we need to set our 15 to 0. Okay. And yeah, I guess we can just read each character. Oh, and we need to return, obviously. Our 15 is quality saved, right? Yeah, I think so. Read char, and I guess I'm just gonna debug that to see that's working. Okay. Yeah, so we're doing. Wait, no, I messed up. Okay, yeah, it doesn't. Let's try that one again. Linked list arrays. I mean, this is an array, technically. Why am I rich arrays in River? Well, okay, now I overwrote IX perfect. I know exactly what I'm doing, as you can see. And that... Wait, that didn't even read anything. Wait, that's wrong. That should have blocked... Oh, I never actually... never actually did this call. Oh, that explains why that's not working. And IX is 0. What am I doing wrong? I'm calling read on standard in. What am I doing wrong? Ah. Oh, it skips the refill? Why does it do that? Oh, because I didn't actually reset R15? No. No, R15 is 0. Right? Yeah. Why are you skipping that? Oh, because I'm comparing with the pointer to input buffer capacity, not the value. Okay. And segmentation fault. Woo. Okay, but where is it seg faulting? Where's that? Move IX what? Input buffer capacity. Is that not how I'm supposed to move into that? Oh, that should be fine, right? Moving into this DQ IX. Can I inspect that? I don't think I can. Actually, no, I can. If I do this? No, it's print, I think. It's 0, apparently. Okay, that's correct. Yeah, should be 0. I've set it to 0 down here. What's in Ix? Why is that negative 14? Oh, it failed. Wait, why did read fail? I don't want to deal with that. Wait, what does read return? Linux reads this call. That's good. Turns the number of bytes read. 0 is end of file. And negative 14. What's 14? Isn't there like an error? No. Oh yeah, 14. Bad address. Oh, I've had that last time, I guess. Why is that a bad address? No idea. Why is that wrong? I guess I should maybe actually read the file. Yeah, let's do that. It's actually yeah, let's actually read the file, because why not? Instead of reading from standard out, so I guess input file is db, right? db input.text. I have a comma 0 in my other file. I don't know what that means. Why did I do that? I guess I have some reason. I don't know, let's copy that, because we're not. Right, so I need to open the file descriptor first. No, actually, wait. I need to open the file descriptor and start before I do anything else. So this is going to be a quote word, and we don't care about the initial value because we're going to override it anyway. Okay, so we're going to do an open. Open is 2, I think. Yeah, that's 2. And it takes a Shasta file name, right? So that's input file as a pointer. And it takes flags. I don't think I need any flags. In ASL. And a mode. I hope I can just set that to 0. And syscall. Then 50 Ix. Right. Let's annotate those just to be sure. No, those are flags, and that's the mode. Segmentation fault. Where did it sig fault? After the syscall again. Why? Ix is 3, that's correct, yeah. So that worked. Is it not bad? Wait. Can I not move into that? Yeah, I can. Wait, why can't I move into FD. What did I mess up? Huh? Okay. I'm moving IX3 into FD. That should be correct. Yeah, move, keyword, pointer, whatever, IX. And that's a DQ0. Yeah. It should work. If I do this, that's probably not even gonna compile, right? Yeah. I can only move, I can't move into pointer, I can only move into the location the pointer points to, obviously. What's wrong here? Like, I don't want to dynamically allocate anything, because that's, like, I don't want to depend on libc, that's boring. I could just write C in that case. And, I don't want to deal with, like, mmap or, like, sbreak in assembly. I guess I am genuinely confused with what's happening here. Oh yeah, you can. That's good. That did not work. Okay. Anyway, edx0, correct? This is car, yes. And moves 3 into IX. Yeah. Now it's segfaults. Okay, let's not worry about that. Let's just use R14 for now. Yeah, and I guess we'll just... Yeah, who needs 15 registers anyway, right? Should actually do that. Wait, what's happening now? It's waiting on standard. What? Okay. Oh, right, because I'm reading from. Oh, I'm still reading from standard. Right. I need to read from 14 now. Wait, but now it's properly reading from standard, and then segfaulting. And it's segfaulting at this one, because I forgot how to move into data, apparently. Let me just look that up real quick. I genuinely don't know what's happening. I have my input buffer capacity. That's a DQ0. That's exactly what I had last year. Yeah. Input buffer capacity. Now I'm moving into square brackets input buffer capacity. Okay, you know what? Who needs who needs static data when you have registers? That's not gonna work for long. So I guess let's use R13 for that. buffer capacity should be R13. I'm gonna run out of registers really quickly, but I don't know how to do that. That seems good. Hi, Dave. That's correct. And reach R, and now IX is 0. Wait, that's... oh no, it should not be 0. Fuck. Okay, that absolutely did not work. Yeah, okay, great. So I guess we need to step into that right now. Okay, so it's hopefully, yeah, it's not skipping the refill this time. That's good. Yeah, wait, why is it? Oh no, that's correct. Yeah. Moving, yeah, 14. That's yeah, 3. That's correct. It's moving buffer correctly, and string this is core. That returns -14. Perfect. Bad file descriptor. Okay, so I messed up on something there. Why I opened the file correctly and returned 3 then, and then read char, it's returning -14. So that means bad file descriptor. Why is that happening? Why are you returning -14? Wait, why? Why? I'm reading, that's correct. I'm reading from, wait, it's not standard anymore. That's file descriptor. No input. I'm reading into the buffer. Should be correct. Oh, I remember something like this last time. What am I doing wrong? I'm just trying to read from a file. It can't be that hard, right? Okay, so input buffer. Yes, that's correct. That's correct. And that's also correct. 3 is not a bad file descriptor. What? Okay. Let's debug, I guess. Let's go. 3. Right. That one did not fail. It opened the file correctly. And now 14 is 3. That's correct. And now it goes with char. And goes for the refill. And that's correct. It writes 3. And it writes, yeah, 1496. That's correct. And the score and -2. -14, I mean. What's happening? Why? Why is the reading a file failing? I'm also not doing any error handling, obviously. Oh, do I need to... oh, wait. Is it... do I need to give it any other arguments or something like that? So open takes file name, flags, and mode. Oh, I'm opening it in the wrong mode, probably, right? Yeah, that's probably what's happening. Yeah, Pixie, I saw your tweet about part 2, and I'm a little scared because I'm kind of struggling already. but, you know. Oh yeah, I'm opening the wrong mode, I'm pretty sure. Right? Open takes. Flags in the mode. Mode can be. What can mode be? Where is mode defined? Walking through. I should probably switch my screen over. Oh, that's the wrong window. Wait. Let me just fix that quickly. Okay, perfect. Right, so waiting through man pages like this is interesting. Or read only. Yeah, what's read only? Defined respectively as 0 and 2. Okay, wait, so read only is 0? Or what does that mean? Wait, does that mean read only is 0? Guess so. And flags are. What are flags? Hello everyone. Oh, raid. I could use the raid. Cubix8513. Hi. Hello. Hope you had a nice stream. We're doing advent of code in x86 assembly, and I'm a little struggling because I have written quite a bit of assembly before, but last time was last year's advent of code, and I'm struggling to read a file right now. No, open is correct. What I mean, I have no idea what I'm doing wrong. I guess I thought I was opening in the wrong mode, but 0 is read, right? Yeah, I mean, I somehow managed to do this last year. Just, you know, like I'm running into so many weird things. Like if I'm writing into this static memory thingy, that's just seg faults, and I don't remember why, because that worked last year. So I'm just using registers for now, but we'll see. So what did I do last time? I set that on the stack somehow. What was I doing? Jesus, okay. Yeah, I'm just doing that as an individual thing. I'm not really doing. No, I didn't do. I didn't Cubix. I didn't do the entirety of Advent Code 2022. Only like, I think I stopped after day 7 or 8 or something. But mostly because I didn't have time. Not also because assembly would have gotten pretty difficult. But like once you get the basics down, it's actually not that bad. It's just kind of annoying to debug mostly. Yeah. It's just a lot, like doing one thing or doing 2 changes a day. It's if you have other things going on, it's kind of a lot. I don't know how to switch my screen to another VS Code window. I don't know. Oh, you're doing it in Rust? That's cool. Yeah. Rust is a nice language. Yeah, this would be so much easier in Rust. And like apparently part 2 is difficult today, and I haven't even gotten past reading the file for part 1, so we'll see. But apparently I stored the result on the stack somehow last time. Hello, Boomerang. Yeah, what's the time? It's 8:41 right now, because I'm in Germany. Hello, Ryan. How are you doing? I'm just to give you a heads up, I'm slightly struggling to read a file right now, and I don't remember how that works. What was I doing? Like, the open is not failing, but then reading the file gives me bad file descriptor, and I remember having a similar issue last year, but I have no idea how to fix it. Yeah, so I did exactly the same code as I have right here. I just saved it in R15. That's the only difference. Then reading. RDI 14, that's correct. And then move SI hop buffer. No, it can't be. Wait, if we just do this, which is, well, it's gonna break everything. If we just try that, it's still sec false. Yeah. Oh, nice. I'm also not using libc, but yeah, kind of regretting that a little right now. Wait, where was I? Add? No, I can't really do that. One. Wait, one. No, that's good. That's correct. Elixir. Oh, you don't have time for Akame. Oh, that's unfortunate. Yeah, Akame is nice. You should try it. Wait, that didn't sec forward. Why did that not sec forward? Is it the size somehow? It's too large. Oh, you want to try it in Haskell? That's cool. Haskell is my main language actually, so you know. Oh, it's nice to see people trying Haskell. Ah, that's the wrong one. Wait, so somehow this is returning bad file descriptor. But when I had just the stack pointer here, that was fine somehow. Why? Oh, input file. Oh god, I'm that's the wrong one. I want to move into the input buffer, not into the file, into the text. You're not too dumb for Haskell. You can't be too dumb for Haskell. Okay, so thing of Haskell is there's a lot of how do I phrase this diplomatically? There's a lot of concepts that are poorly to not at all explained in Haskell. Like you don't like monads are not complicated, and I'm serious. Like they're really not. It's just that Haskells are really terrible at explaining monads, and like querying is not that hard. Function composition really doesn't mean much on top of just, you have two functions and you can stick them together and you get a new function. So like, yeah, this Haskell is a lot more inverted out. Haskell is a lot scarier than it actually is. And then it has to be. Communication with that. Yeah. I don't know, Haskells. I mean, some Haskells are really great at doing stuff. Type level Haskell. I actually did one thing, one day in type level Haskell last year. That was kind of fun, but it's not. I mean, it's not that interesting because you just use like type families, and that's just type level functions, and then yeah, it's just kind of unergonomic Haskell basically. Right, so what was I doing? I was doing, yeah, right. I actually used the right buffer this time. There's some way to set the default layout in GDB, I think, but no idea how. Okay, so IX is what I'm doing. Yeah, I'm reading the correct one and bad file descriptor. Why is this returning bad file descriptor? If I just read one byte. I think Haskell is great for introducing fundamental concepts. It's just that when you look at others' code, it's very hard as a beginner to folks building their favorite language extensions or something. Yeah, so the thing is, like a lot of Haskell code is really weirdly written with like single letter variables and stuff like that. But like it's really not. Like if you look at any of like Gabriela Gonzalez code, for example, if you look at like, I don't know, I can give you something like types, for example. That's amazingly documented, just an amazing library, very well written. But it's just not everyone writes like that. So like, if you look at this, for example, that's just like, come on, just appreciate how amazing some Haskells can write code, and others just don't. I think everyone should try language with type signatures. I like error this, error, oh my god. Yeah, I mean, that's just currying. Actually, I really dislike currying, especially in Okame. Like, I don't think Haskell is that bad because it's pure and lazy, so it doesn't really make that much of a difference. But like in Okame, you can have like a function where partially applying the function performs some side effect, and then currying doesn't actually work because you have like if you partially apply the function, that's not actually the same thing as if you apply it twice, right? If you do like f of x of y, or if you do like and then f of xz, something like that, or if you do like let g equals f of x in g of y, g of z, that's not necessarily the same thing in Okame. In Haskell it is, because like f is pure, so it can't do anything else, but in Okame these might do different side effects, and that's really weird. I really don't like that. And it really doesn't buy you much. Like, you get partial application for free. Okay, cool. Yeah, partial application labeled arguments and optional arguments. That's... yeah. Not great. I mean, labeled arguments are really nice. And optional arguments are also really nice in Okame. It's just, yeah, if you put them together with currying, no. Like, syntactically, the whole trick behind like Okame syntax that like this is really just like parsed left associatively, and that those are the same. That doesn't actually hold anymore if you have labeled arguments, because like if you do this, that's not the same thing. This one doesn't compile. This one does. Yeah, I don't know. Well, actually, it does if W is a named argument, just not if it's an optional argument, I think. Yeah, pretty sure. Yeah. And that's why we're doing assembly. Okay, now if this gives me bad file descriptor again, I have no idea what's... Okay, of course it does. God damn it. Something about my OBS doesn't want to capture my screen correctly. That's better, right? Yeah, somehow if I like tap out, OBS just stops recording my screen for some reason. Right, but okay. What's happening? I don't know what I'm doing. Like, this was working correctly last year somehow, and I'm using the same code pretty much exactly. Yeah, I think. Yeah, perfect. Wait, what am I doing? Move IX0. Yes. Move RDI FD, that's a 14 now. That's correct. Move RSI input buffer. Move RDX, the capacity, that's just one, because I'm trying to try that. And syscall. Yeah, that's exactly what I'm doing. What? I'm so confused. Wait, does that? Wait, let me just try to compile the one last year. Yeah, that one works. What am I doing differently? What? I'm so confused. It's literally the same code. Like this. Okay, I just copy this over. Like that's what I had last year, right? Section.data. Oh, there's no colon. Oh my god. Is that doing a difference? Is that seriously doing a difference? Is that? Wait. Wow. Okay, wow. The difference between this and this is that this one isn't actually data something. And so this one, I don't know, moves those somewhere where its memory is. Actually, I think this one is code, right? Yeah, or something like that. So I think if I do this, those are labels or something. No, actually, they can't be labels. But this is in the code segment, and so this one can't be modified. And that explains why we couldn't mutate the capacity earlier. Oh my god. Wow. I'm genuinely speechless right now. Jesus Christ. Like, who designs these assemblers like that? Who made that decision in NASM that putting the colon that transforms that into a code label? Oh my god. Okay. But I think we can redefine now. Okay, so we can actually move this file descriptor to its own thing now. Okay, so this calls char, and that returns 54, which is probably 6. Yeah, that's good. Yeah, perfect. Okay, it's working. We've got something working now. Finally. Okay, so we can read characters after... How long have we been streaming? An hour. Perfect. Okay, so after an hour, we can finally read characters. And now we can actually do the interesting bit. Yeah. Oh my god. Okay, so you can read a character. Yeah. Right, so we are gonna do the actual change now. I almost forgot what it was about. Right, we need to check the first and last number per line. So that's gonna be pretty easy, I think. So we can just do our main loop. And I guess we're gonna read a character. And if that one is 0, that means we're done. So actually let's let's do training new line because that makes things easier. So this is our line loop. If that's a 0, then that means we are done, and we just need to add up. No, actually we don't. We just need to print the result. So print the result, I guess. And until then, if that's not 0, wait, test. What's the thing for testing? How do you test things again? Test like 0 and equal? Yeah, I guess it works. I don't know, it's to compare. I don't remember how test works, but I remember that it's kind of strange. So let's not do that. Let's just compare and then jump if it's equal. Right, and if it's not 0, we'll do another comparison with new line. What's a new line again? Yeah. That's 10, right. So if there is a new line, we're gonna jump out of our inner loop. So I guess this is our actually no, this is our yeah, I guess this is just gonna be our inner loop, why not? So if we find a new line, we're gonna jump out. And I don't know, do something. And then jump back to our line loop. Right, and continue reading a new line now, because we just read a new line. Okay, and if we don't do that, if we haven't found a new line yet, then that means we have a number, and that's from inner 0, and if that one is, we're gonna subtract 49. 48, I mean. So that means convert digit to number. And if this is not, and so if it's larger than 0, no, if it's less than 0, yeah. We're gonna just, yeah, it's smaller than a character, so we can just jump out of the loop again. This is it's smaller than like ASCII 0. So that means we can we don't care about it because we only care about digits. And if it is larger than, I guess, 9, wait, after 1 earth, if it's larger than 8, because 0 is 0, no, wait, 0 is 0, and if it's larger than 9, I hope I got this one correct, then we are also gonna jump out. Actually, the smallest digit is just 0. We can just skip it again. Oh wait, we need to actually read a character here as well. You know what? Actually, let's not do it like this. Yeah, let's not do two nested loops. Let's just do one with like a jump out of it. So we're gonna read a character, and if we're at 0, we're gonna jump to done. Yeah, we can actually just keep that. Yeah, we can just keep that in our main loop. And if it's a new line, we can jump to loop done is now. Yeah, no, that's fine. And then we just jump into the loop again. Yeah. Think. Yeah, that works. Okay, so we know rex or ix is a valid digit now. So I guess we can like use 15 for first digit and 14. Or actually, it's a bit in reverse because it's confusing for our last digit. Yeah, and we're just always going to override our 15, and we're only going to override our 14 if it's the first time we're overriding it. So if it's, I guess we just reset it to -1 or something. And yeah, so right, if R14 is -1, only in that case we are with cmove, what's cmove? Cmove equals. We do a conditional move. So only if this one is equal, we move ix into R14, right? And but we'll always move ix into R15. And I think that's the main idea already. And then that's gonna iterate until it hits a new line, in which case this is gonna run and this is gonna jump to loop done. And right, so we actually need an accumulator. It's at the top or something. So that's the total sum we have accumulated so far. But because we're only looking for the sum of the numbers in each line, so we can just accumulate those in R13. Okay, so we're gonna move. We're gonna multiply the first digit by 10, so that we can. We need to add the two, or we need to concatenate the two digits, right? So if like 5, let's say we have 5 and 6, then we can just we want to get 56, and that's the same thing as doing like 5 times 10 plus 6, right? So we can just multiply that one by 10, and then add 15. And right, now that we have that, that's our sum for this line. So 14 now contains our, or not our sum, our 2-digit number for this line. And that means we'll add it to our accumulator. Okay. Right, so our accumulator has been updated now. Now we can reset our 14. So our first digit. And I guess we can just, yeah, we can just start again. Right, and once we hit in EOF, we can, we actually need to printing logic. Oh god, okay. So that's gonna be fun again. Right, but now our 13 contains our number. So I guess we can, I'm gonna make a function for that. So let's put that into RBX and call print number. And then just exit, yeah. Right. Okay, how is print number gonna work? Right, so how do we print like decimal digits? So I guess if you actually like 1, 2, 3, 4, 5, actually, no, not can have as many digits as we want, yeah, we can't do any simplification like that. So if we want to print like 1, 2, 3, 4, 5, how are we gonna do that? So I guess we do, we divide that by 10. Over 10, and that's gonna give us the last digit, right? So that's gonna be 5. That's gonna be 1, 2, 3, 4. It's gonna skip the last digit, and if we do mod, which diff does in one go, then we get the last digit. And we just do that for everyone. So we get our digits in reverse, and then we just print our, I guess we just write them on the stack in reverse. I guess that's the easiest way to do it. And then once we have like, so we have like 5, 4, 3, 2, 1 on our stack. And then wait, the stack goes downwards. So if we do that, right, we write 4, wait, we write 5, and then we write 4 below that, 3 below, 2, and then 1. Yeah, that's perfect. Okay, so if you just, yeah, we can do a really cool trick here. Because on x86, the stack goes downwards, right? That means if we have, like if you imagine the stack as like an actual stack of things, like that are vertically stacked, then it's not like, if you have 1, 2, 3, they're not actually organized like this, such that this is a higher address, but they're in reverse, right? So lower address, the top is at the bottom of the stack. And that's actually useful for us, because if we just push each individual digit on the stack, and we push those in reverse, so we push 4, then 4, 5, then 4, then 3, then 2, and then 1. And yeah, if we do that, then if we take the stack pointer as our buffer, then this actually points to a growing, like then that buffer is going to be right bottom to top. So growing upwards, because buffers grow upwards, obviously. And so then we'll read those in the correct order, hopefully. Okay, right, so 6 number in RBX, and it does something to it. Actually, I should, maybe I shouldn't use RBX, because that one's not callie saved, I think. Oh, not caller. That one might be overridden by system calls, is what I'm trying to get at. Yeah, I don't know. Let's keep that in RBX for now. No, actually, RBX is caller saved, I think. If that opens somewhere. Right, sometimes registers. I don't know. Yeah, that's fine. I don't think RBX is caller saved. I think it's callie saved. Are you following C calling conventions, or is that for syscalls? That's for syscalls. Syscalls follow kind of C calling conventions, not quite, I think, but almost. Yeah, but that means, yeah, so you do need to worry about caller saved and callie saved registers, because syscalls worry about those. But I'm not calling into any C. And I'm just doing my own ad hoc calling conventions because it's simpler. Yeah, okay. Right, so we have our input in RBX. And that means we need to, I guess, first of all, write our print loop. And we'll say if we've hit 0, then we can stop. Yeah, and we need to reset our stack at the end somehow. Okay, that's gonna be complicated. Actually, before we do that, let's try just running this and looking at the result in GDB. Yeah, I think so. Great. 71. What? Oh, that's, you can't multiply by an immediate, I think. Something. Why? Okay. No, that's, what? 72. You can't multiply register by register? What? I am so confused. Wait, I need to find the... It's actually kind of hard to find like a good reference in x86 instructions somehow. And do I need IMOL? Does it make a difference? Oh, it does. Okay, well, I guess I just do IMOL. What does mul do? Unsigned multiplier. Why is that one not allowed? I don't know. I'll just do IMOL, I guess. Doesn't really matter, because they're all positive anyway. Or, well, yeah, our inputs are all gonna be positive anyway. At least. Right, so that's correct, and then we don't have print number yet, so let's just skip that one. And can break on, what's that one called? Is it started done? Yeah, cool. And now run. What is GB doing? Oh no, something's going in an infinite loop. Oh no. Okay, so let's make start, run. Let's step through this. Okay, so that's working. Rechar's working. We're here. That's correct. We're not done yet. It's doing stuff. Yeah, IX is 6. That's correct, right? Yeah, that's correct. Perfect. Okay, so the first one is working. And it's should be moving that into F14. It's not moving that into F14. Why? Because F14 is 0, because I haven't initialized it correctly. Huh. But that's not the actual issue here. Just... Oh no, that is... I don't know, that might mess some things up. Actually, let's break on... Yeah. Let's break on loop. Okay, so that calls rechar. That reads, yeah, that's correct. Subtracts that, yeah, so that's 6. And then it should move that into F14. Yeah, perfect. So that's working. And now also into F15. Oh, did I not use F15 is a buffer index. Oh god, that was not meant to do that. Let's use R12 here. I think I11 is not quality saved or something. I remember something like that. Yeah, it's still going in infinite loop though. It does go through all the numbers. It's just going in infinite loop there. Okay. Why is that happening? Okay, that's... yeah. I shouldn't have done that. Okay, so let's go with instruction by instruction. Okay, so it's going through... so actually, let's put a thing there. Let's put a breakpoint, label there so that we can break or not. I guess that's a breakpoint. And now we can look at the character that's being read. Oh god, what's happening for music? Okay. Wait, I messed up already. Yeah, so that's 55. Wait, what's 55? 7. Yeah, that's correct. That's 7. Wait, what? No, that's wrong. Or am I? Oh, I need to step one further. Huh? Yeah, I do. Wait. Redo that. Debug. Okay, so that's 54, that's 6. And why is it not going, actually breaking on debug? I don't know. Yeah, so that's 55, that's 7. Is it? Yeah, that's 7, that's correct. And now it's 57, which is 9, yeah. Now it's 56, which is 8, yeah, that's correct. And, oh wait, let's look at our accumulators. R14 is 6, that's perfect, and R12 should be 9. Didn't know enum for Charles was reliable. He's churned out. It is, I think it is reliable, I'm pretty sure. I know it has always worked anyway. I think those are just aliases out in char. And to use to enum I don't need to import anything. So that's easy, I guess. Yeah, okay, wait, where was I? Okay, so R12 is correct, because until now the last digit was 9. Now it's 115, that's going to be an S, right? Yeah. Yeah, that's an S. Yeah, no, it was. So it's an S, and then, wait, yeah. Okay, so far everything's going to plan, and R12 is 8, and R14 is 6. Yeah, perfect. That's exactly how we want it to be. So let's try the next iteration. And 14 and 12 are still... Oh, no. Wait, what? Oh, no, I'm wrong. 9. Yeah, F14 is correct, yeah. That's the instruction pointer, that one's supposed to be weird. Okay, so it's working, presumably. Now that's 118, that's V, yes. So I can skip one. That's 101. That's the E. Wait, didn't I skip that one? Guess not. 110, and that's the N, I guess? Yeah, that's the N. Okay, and so the next one is gonna be a new line. Yeah, 10, perfect. Okay, so it's not an end of file yet. It's not gonna jump out entirely, but it is a new line, so it's gonna jump to start loop done. Yeah, perfect. Okay. So that's one iteration of the loop, or the first iteration of the loop at least, should work correctly. And now we're doing, oh wait, RBX, that should be 10, not RBX, but that's not the issue probably. We're adding 8, yes. And yeah, adding that into R13 and resetting R14. And jumping back to the loop, yeah. Okay, so the first iteration seems to have worked correctly. No, yeah, and now the first character is an S, so we should just skip the loop here. Yeah, and now the next character is something, okay. And yeah, that's the first digit, that's an 8. Okay, so we have, wait, the first digit, is that an 8? Yeah, that's an 8, that's correct. And yeah, 8, so we're gonna compare 14, which is equal to that, so 14 is gonna be set to 8, the first digit, yeah. And R12 is gonna be set to IX. Yes, that's all working. I guess let's break on loop done. Let's try that. So we can like see every line, and actually I'm gonna delete all but the first 3 lines, I guess. Oh, it's the training new line, right? Oh, it's gotta be the training new line. But what if I just remove that? No, that's not it. Okay, but let's just remove everything with the first like 3 lines. Yeah, let's do 3. Let's break and loop done. Layout our assembly again and run. Yeah, so R13 is nothing yet, right? Because it's the first iteration. But R14 is 60. What? Oh no, yeah, right. I've multiplied that one by 10. So yeah, it's 6, not 60. And now it's adding 8, so it's 68. That's exactly what we want. Now it's resetting R14 and jumping back. And R13 is 68. Yeah, that's correct. And on the next one, it should be 8 and 2. Yeah, it is 8 and 2. So that part's working. Perfect. So yeah, right. And last 9. And that one should be 5 and 4. And it is 5 and 4. Right. And now jumps to start. And I'm confused. Where am I? Oh, right. Start loop. No, what? Wait, what's happening? Oh my god, what did I just do? Is this jumping to the wrong thingy on 0 or something? Oh yeah, no, it's not. It's jumping to done. Let's restart. I need to select that. Okay. Yeah, so that's the first one. Second one. That one, I guess. Wait, what? R14 is... Wait, what? 5 and 4. Yeah, so that's that one. Yeah, 5 and 4, and it's resetting R14 and jumping back. Okay, and this one reads... What? Jumps somewhere? Oh, I guess I'll read... I guess it's not reading the new line? It's not reading end of file correctly? That might be the issue. Okay, so... try that again. And break read char. Right, okay. So read char is hopefully it doesn't need to... Oh, wait, it's... Oh, I know what's happening. Yeah, right. So we have exhausted our buffer capacity. So this one is 0. Right, yeah, okay. So if ix is 0, then we're gonna run into an infinite loop here. Ah, that's what's happening. Exactly. Okay. So what we were doing before was that we were like refilling, and then once it has been refilled, once it had been refilled, we could use the regular logic for reading from an already filled buffer that has some capacity left. But that's not gonna work because it's not actually being refilled if this is code returns 0. So we need to have a special case where we yeah, we would just return, I guess. So if this returns 0, then you jump to on your F. And that's gonna return 0, yeah. Hey, and that worked. Okay, perfect. That I'm just gonna trust that that worked correctly, and I guess we can do printing logic now. Cool, awesome. Yeah. So that means we can just read. We can do a print number again. And I guess we only need to write this one once, and we can just copy it over for part 2. So that's nice. Okay, so let's take some input in RBX. Yeah, we've already done that. And that is gonna be interesting. Yeah, I'm genuinely kind of scared right now. But it's gonna be fine. I'm sure it's gonna be fine. Okay. So we will need a scratch register. I think, but I don't remember which ones are quality safe and which ones are not. Where do I find that? Here. I think that's. No, that's not the one. Here, if the callee wishes to use registers RBX, RSP, RBP, and R12 to R15, it must restore the original values before returning control to the caller. Okay, so it's RBX, RSP, RBP, and R12 to R15. Wait, those are the only callee safe character registers. That's annoying. Oh, actually, we don't even need to save. Oh, that's fine. We don't need to print anything until we're done. So we can just use like RCX or something. So that's our. Actually, no, we can just use the base pointer. Yeah, we can use the base pointer. Right, so we are gonna push our numbers on the stack like this. This is our stack, and then we have like our base pointer here. So this is RBP, and then RSP is up here, obviously. Although that's a lower address. And our stack pointer is here, and now we're gonna print. Wait, no, wait. Yeah, right. Yeah. And then we use RSP as our buffer pointer, and our length is just RBP minus RSP. Yeah, that way, or other way. I don't know, something like that. And we can just print that one, and then we just restore RSP to RBP and get rid of all of that. Yeah. Okay, cool. So stack pointer. Okay, so first of all, I guess we need to do our loop, and then that one we need to. That's what print loop. We divide RBP by 10. I don't think division. Does iDivision additive take? No, it doesn't. Yeah, I remember that one correctly. You need to you need to use a. You can't do an immediate on division. You need to divide by a register for some reason. Except that also doesn't work. Do I need to do iDiv? No. Oh no, diff is really weird, right? Diff ax equals dx ax what? So this is what it says in Wikipedia. Resulting dx equals what? Like I know roughly what's happening, I think. Actually, I'm using diff, not idiff. Oh, something. So it divides. I think diff only takes one operand or something. I don't know. Yeah, I think it's just RBP, and I move this one into RDX, and then it does its thing. Yeah, okay. So I just move the second one, like the number I'm dividing by, into RDX. And then I'm just doing diff RBP, and that saves the result into, hopefully not RBP. No, not RBP, RBX. I think that would be nice if that. Yeah, no. What? That saves the result into RAX, and the remainder into DX. RDX, I think. Anyway. Let's just try that one, actually. Let's check that assumption before I do something stupid. So that divides, that's 54239. and then that divides that one by 10 ideally. Oh wait, no, RDX is 10, yeah. And that's the remainder. That's wrong. And that's very wrong. That's not doing what I expected to be doing. Okay. Good thing I tried that, I guess. Yeah, and then divide. That's the values in... Oh, by the source operand divisor. Oh, right, so you do... Actually, don't do it like that. You do AX10 and divide that one by... and RDX0, I guess. And then divide that one by 10. Because you can do... I don't know if you can do 128-bit register. I guess you can. Like, if it uses IX and RDX together. So the upper bits from IX and lower... No, the lower bits from IX and upper bits from RDX or something like that. Not like that. You can do an immediate. Wait, this one RBX and then CX10 and diff RCX. I think that's awfully complicated for division. Yeah, so that's RBX. IDX is 0. M6 is 10. And I'm dividing by RCX. Yeah, that... Wait, 5, 4, 3, 2, 3, 9. Yeah, no, that's correct. 5, 4, 3, 2, 3, 9. Yeah, perfect. Okay, cool. So that's working. It's very complicated for division, but I guess it works. Alright, so now IX equals rest, and DX is our digit. Right, yeah. So that's... Actually, no, wait, I did that one. Like, the whole stack trick might not work, because we might need to... Wait. We might need to reverse it, because it saves 1 first. And then it saves 2 below that. Yeah, no, that's wrong. No, it doesn't. Never mind. It says 9 first. Yeah, it works. It works. I'm correct. Okay. So... we have IX and RDX, and now we are gonna... move... I guess I should just take an input in RAX, because that's gonna avoid this whole ordeal. Yeah, I can just take an IAX. It's fine. 13, no print number. So it's the stack pointer, the stat one, and then it pushes the actually byte RDX. Or actually what's the one? LD, DL, DL. Yeah, pushes the lower byte of RDX. Does it still compile? No, it doesn't. Of course it doesn't. Can push take a byte even? Push data into stack. Yeah, that's useful. So that one takes no, if I do that probably doesn't work, right? Yeah, it says ignored. I don't know if I can use push there, if I do need to do the stack arithmetic myself. guess I can just try that. Yeah, sure, let's just try that. So I guess that's ISP minus 1. And that's gonna be RDX. Or, no, actually, a byte AX. Yeah, that's correct. And then we'll do we'll decrement the stack pointer. Oh no, that's not AX, it's DX. And I guess we can just jump to the print loop again. Yeah, and only if oh, actually it doesn't print. We need a special case for 0. Don't need to worry about that right now. But if IX is 0, we can jump out. Jump to done. And we just, yeah, we actually do the, actually no, print result. No, wait, jump print result. Here we can actually do the syscall and stuff. But first, yeah, guess let's add a to do. If Ix is initially 0, we just want to print 0, right? Because our loop is not going to print anything on 0. Because like if we naturally get to 0 by like 1 to 3, dividing that one down, and then getting 12, and then getting 1, and then getting 0, then we don't want to print trailing, leading 0, obviously. Yeah, so I guess yeah, we're gonna need a special case, but we don't need to, like, it's not gonna be 0 right now, so we don't really care, I guess. So at the end, we need to restore the stack. And before that, we will move write into IX. I don't remember what write takes. File descriptor, buffer, count. Okay, so it moves into standard out. Send out into RDI. Well, buffer or stack pointer into RSI. Actually, might need to do stack pointer plus 1. Yeah, I think so. No, actually. Yeah, and we need to grab that one. Actually, no. Yeah, no, yeah, no. Because the stack goes downwards, so if we point at the last element, or if we point at the next one, we could write to, I don't know, I'm gonna try that. We'll figure that out, I guess. And then this is cool, but is there another argument? Probably count, right? Count. Yeah, so move RCX. So is it RBP or RSP? Wait, RSP is lower. Right, so it's RBP minus RSP. And then we move. I guess we don't actually need to use. We can actually immediately move that one to RDX. Yeah. Rather than going through this RCX immediate. We can save one register. Yeah, so it's write to stand out. Here's a buffer pointer, and yeah. So we get the size, and then the score. Okay, so if, big if, we did everything correctly, this is gonna print out some number. Okay, it didn't seg for it, but it didn't print anything. Okay, that's fine. Okay, run. So we can print that we will. Wait, what's happening? Print result. Wait, why is it in print result already? What did I do? Yeah, that's 0. Wait, it's jumping to print result way too early. Why is it doing that? Because ix is 0. What? No. X is not 0. It shouldn't be. Anyway. No, I'm not doing this to score before it. ix 0. Ix is not 0. Oh, I'm doing a jump. That should be jump equals. Of course. Okay, second try. Segmentation fault. That's better, I guess. Okay, so this is doing the division and stuff. It's dividing things correctly. Till there is only, yeah, until there's a 5 and until there's a 0. And when there's a 0, it jumps to print result. And then it already, yeah, at most EDI is 1, that's correct. And as I is our stack pointer, that looks correct, I guess. And size is 5, is that correct? I think so. I think that was a 5-digit number. Yeah, so it's 5. That's good. And not this is score. Wait, what? That did nothing. Why did that not do anything? And now it's resetting the stack pointer and I guess going into retry again. What? Uh-oh. Oh, I think I messed up the stack somehow. Oh wait, I can't have messed up the stack. Oh, I guess I could have overwritten it? No, I can't have overwritten the stack. What should I do? I mean, I have this one here for a reason. Hello. Oh, right. Where did I do move 0? Oh, I did it. I guess it makes, yeah. I just had that because it makes sense for the thing, I guess. Hello, by the way. I'm not sure if I'm calling for readability. I'm just trying to get something working, to be honest. So, you just came in, I guess, but I've been writing this for almost 2 hours now. We spent the first hour figuring out that I had a colon here, which meant that this wasn't actually data, but code, I guess, and so it wasn't mutable, and so trying to write to any of those with segfault. Yeah, that was fun. So yeah, I'm just trying to get something working. And apparently part 2 is pretty difficult this time. So yeah, that's gonna be fun. Yeah, but I'm almost done. I'm just doing the part that actually prints the result right now. And once we have that, yeah, we have part 1. Okay, but this is segfaulting somewhere and I'm not sure where. So, Yeah, so nothing. Stack pointer, that's correct. Oh, that should be. Hey, that should just be correct actually. Let's fix that one again, I guess. 4, 3, 2. Yeah, that's 5 digits. That's, yeah, so our count is correct. Why is this syscall not doing anything? Yeah, our size is 5. That's what I'm trying. Yeah, that's correct, I think. Yeah, size is 5. Buffer is correct, I guess. Actually, let me just print. Wait, what? How do I? Oh, how do you do that again? Does it show? No. But there's some way to like evaluate the thing at that, like to dereference the pointer. Look at that. What's it called? It's not print, it's not show. Display? No. What does file do? No. No, cross? Oh, it is print. Oh, it's just, right, I need to do $sp, I think? Yeah, okay. So if I do print $sp minus 5. Wait, no. What's that one? CB. Yeah, perfect. Okay, so if I dereference that one as a char pointer, that's zeros. That's one. Oh, I'm an idiot. I don't actually just need to push those. I need to, yeah, it's just a number. So I need to add rdx 0, 48. And that's a false. Oh, but it printed a 5. Oh, so it prints 1 digit. And it prints the first digit. That's a start. And now if I... No, it hasn't focused. Now if I print dereferencing as a char pointer $sp minus 5? No. Can I do that one? What ASP itself? Okay, that one is right, so that one as a char pointer. Oh, right, I need to dereference as a char pointer. Why is a char array 5 pointer? Okay, so that's a 9. That's Good. That's what's supposed to be there on the stack, I guess. If I do -1. Yeah, no, that's good. I think I just need to step through this one a bit more. Right, so 2 is on the thing, and if I do -5, those are zeros, right? Oh, +5, because it's plus. Ah, but that doesn't look correct. What? I'm very confused. Oh, I think... Wait, is it because I need to... Does this switch off already? Because C actually doesn't add like bytes, but it adds whatever your actually it should just be ASCII. It just adds whatever your element of the array size is. So it like ASCII is that, and ASCII +1 is no actually +1. Okay. Because it's a void pointer, right? So that's not it. That's weird. Does that work? No, that still prevents the chance thingy. I guess let's just print this individually. So ASCII +1, no. Those are wrong. Those are being reset somehow. But why? Why is my stack being reset? What's happening? Is this just not working? Oh, is it? Oh, I need to... Is that what I need to do? No. Oh, because I'm pushing dx, but I want to push dl, right? Yeah. Oh, I was overriding the previous character every time. Yeah, and it works. And it works. And I forgot to train a new learn, but I guess it's just move ASP -1 is a byte. 10. Yeah, perfect. 54 milliseconds, that's kind of long. Woo, we got it working. Finally. Okay, let's see if that is actually the correct answer. I just switch my screen quickly. And drum roll. Yeah, perfect. Ooh, 1 gold star. Let's see what Fudge is like if I'm gonna do that one today or if I'm gonna do that one tomorrow. The calculation isn't quite right. It looks like some of the digits are actually spelled with letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Also count as valid digits. With this new information, you need to find the real first and last digit on each line, for example. Wow, that's awful. Okay, wow, that's oh wow. So, Pixelero, if you're still here, I know what you're talking about. Okay, but actually I think that's not even that bad, maybe? Because we can just do like a try, right? We can just like hard-code a try in there. Just wait, let me just actually copy that one, because part 1's working now. What we can do is, I guess, like we can do a prefix tree, right? We have, wait, which ones do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what we can do is we can check if we find a 1. Then, oh, thanks. Yeah, I forgot to switch my That's better, hopefully. Okay, so what we can do is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if you see an O, then we know that one can only be N and E. So we can actually just compress that one. So we have we know it's either going to be 1 or it's going to be so like if we start at nothing, then we have the option that it's going to be 1. Actually, yeah. Well, it's gonna be a T. And if it's a T, then it can be 2 or 3. Right? So then it's either... Yeah, we can do like a radix try, basically. So it's like T could be 2 or T could be 3. And then if we have... actually, it's not that bad. We just need to hardcode a radix try, basically. And then if we have an F, then that one can be 4. Because those don't actually share that many prefixes. So we basically just need to dispatch on the first character and check that the remaining ones are correct. I think. Oh, actually, no, we can't do that. Fuck. Can we? Yeah, we can. No, we can't. Because I thought we... Actually, no. No, it doesn't work. It doesn't work because we need to backtrack, right? If we have like F1, then 1 is what we're looking for. But if we pass the F, we're gonna pass that as a 4. And then we need to backtrack and see that the F was not, like, go back to this O. Oh, that's bad. Ugh. Oh, I know what you mean. I absolutely know what you mean. Okay, so I guess this radix try might still work, but we need something else to do backtracking. I guess actually we know... Actually the length is bounded, right? So we only need to remember up to... What's that, like 5 characters? So we can just remember those and like replay them, but that's also... Oh, that's gonna be really difficult. But anyway, let's just finish this one, just to have something, I guess. Wow, that's day 1. That's impressive. 8 and N, it's just 9. Okay. I guess it's not the worst, though. Oh, and we need to... Yeah, no, we can convert those back to numbers, that's easy. Okay, so... yeah, right, we can leave the remaining scaffolding intact, basically. And we only need to change the loop. Okay, so we can keep all the machinery with 14. We only need to check this to change this part, basically. Not just only this part, but something like that. Okay, so instead of this, we need to do something way more complicated. So, what can we do here? Actually, we can do that even more interestingly. We can sort those and do like a binary search tree try thingy. So, that would be E. I guess we'll do that when we get to the part, but yeah, we need like a look ahead buffer or something. Actually, I think that's doable. Yeah, so we have like a look ahead buffer. Look ahead buffer, and let's set this one to be like, I don't know, 10, because why not? Yeah. and that one's 0. So we're gonna remember how many characters we skipped. Or we're gonna remember every character we look at, and if we don't find a digit, then we'll backtrack and use those on the next iteration. So I guess instead of calling read char, we'll need to check if we have something in our lookat buffer. And so we also need to like what should we call it? I guess we look at index just. Yeah, just our index where we're indexing into the lookat buffer. In case we are backtracking. Right, yeah, okay, so that makes sense somehow. Okay, so instead of just resetting our 14, we also need to reset our lookat size and our lookat, no, not our look, yeah, actually also our lookat. No, we don't want to reset the size. Yeah. Wait, oh, we need 2 lookat buffers. We need the previous one and our new one. Because we need to look into the old one while remembering the new ones, yeah. Oh god, that's gonna be so painful. Yeah. Yeah, right, and then we can just copy those over. So it's gonna actually, so lookat buffer, we're not gonna need that one anymore, are we? No, we need to, that's annoying. Jesus, that's so complicated. No, actually we don't, no, we're not gonna do it like this. We'll do like a loop in here. Instead of just calling read char, we'll do a read digit loop. And yeah, okay. So what are we gonna do? If we have if our lookat buffer, if our lookat index is so the characters we've looked into the lookat buffer. Yeah, right. If no, that's okay. Wait, we need a function. Yeah, we just need a function, I guess. So we need a read character with lookahead, I guess. And so this one is gonna read character with lookahead. Yeah, and read character of lookahead is gonna wait, what's that one gonna do? I guess I would just compare if we have exceeded the lookat buffer already. Can you do compare of 2 like memory locations? I don't think you can. This should probably be register anyway. Right, lookat buffer size, and if it's greater or equal, we just going to buffer exceeded, I guess, and we'll just move ix. No, we just call or jump, I guess. We can do a tail call and read char. And otherwise, move look ahead buffer plus yeah, actually get index, and we move that one plus LX. So we return the character at the look at index, and then increment look at index and return. I think that should work. I was going to just save character, I guess. Yeah, so we'll just move that one into the buffer, increment the buffer size. Oh, actually no, that's the next look at buffer. New one. And then return. Yeah, so that's how we save one character. And that's how we read one character with look at. And then, yeah, and then we... Okay, so it's not that terrible, I think. You can read one character, jump now, read digits. Yeah, can read one character. And now we can do our try. I guess, yeah, just a linear comparison. Wow, that's gonna be a lot of code to just match on the strings like that. And I wish I was writing like a camera Haskell right now. That would be so much easier. I mean, I guess that's what you get for writing things in assembly, but you know. Okay, so I've read one character. Now I'm gonna compare that one. Oh, hi Teach. Oh, wow, 200. Oh god, 249 views. Hello everyone. Well, I was not prepared for that. Hello. Yeah, we're doing Advent of Code in x86 assembly. We've done part one. Part one works in only 142 lines of assembly. And we're doing part two now. We did just a teach and make you react to theory, reacting to prime, to reacting to professor, reacting to prime, reacting to FP. Jesus Christ, teach. Oh, but I know which video you're referencing. That's cool. Awesome. Nice. Yeah. Cool. Yeah, so, yeah, we're doing this the second part of today's Advent of Code. And that's, so, yeah, I'm just gonna pull up the problem statement. So if you don't want to be spoiled, look away now, I guess. Yeah. So if I, yeah. Here, so first half was that you have an input, and that one contained like digits, and you're supposed to take the first and last digit in that per line, combine those as one number, and then add all of those up. And part two is same idea, but digits aren't like ASCII digits, but they're actually text. So you have like 2 is one digit, and 9 is one digit, and so now you need to match on text in assembly, and that's gonna be really fun. Bye, Teach. Could we attempt to use NeoVim? I've I've tried using NeoVim. I'm gonna get into it eventually, I guess, but I don't want to do NeoVim and x86 assembly at the same time. Yeah, I'm doing it in assembly. Yeah, so this like text matching is really annoying. So yeah, I have an idea. We can basically do like a an inline radix, or not inline, but like an hard-coded, I guess, index try, radix try. So if you don't know, a radix try is like a prefix tree where you match on one character at a time, and then you have like a tree structure where you first compare the first character, and if it's an O, you know it's a 1. And if it's a T, it can only be 2 or 3. If it's an F, it can only be 4 or 5, and so on. Right? And so the idea is that if we see that the first character is an O, we only need to check that the next two characters are N and E, and if it's that, it's definitely a 1, and if it's anything else, it's not a valid digit, right? And similarly for like T, we can check that it's either WO or HREE. And yeah, those are all the possibilities we have. So it's actually not that terrible, but the difficult part is that like if we have something like I don't know, T1, right? Then it's gonna actually let's do F1. Then it's gonna match F, and then it's gonna match O, so that might be 4, but it's not 4. So we need to backtrack and actually skip the F and start at the O again. So we need to remember which characters we read. We can't just stream through all characters, like one by one. We need to do this more intelligently, and that's why we keep a buffer around. Oh god, yeah. Somehow my OBS doesn't wanna collaborate today. Okay, right. So you weren't even seeing that in extra, right? It's radix try. Okay, so I just said it wrong again. We have radix try where you can match on like OOT and all the characters. That's better. And so, like, if you have an O, we know it has to be 1. If you have T, it has to be 2 or 3. If it has F, we have an F, it has to be 4 or 5, and so on, right? Yeah, so if we have something like F1, we're matching an F, and then we're matching an O, and then it's not 4, so we need to backtrack and like start at the O again, even though like the first character where we found out it's not 4 was already the N. So we need like a buffer where we can where we like save the characters we've read, and then we can restore those and like read from the buffer on the next try. Yeah, and I think that's actually not even that terrible, because we have like a read character of lookat function that just I don't know if that compiles actually. It does. Oh no, it's part 1. It does not. Oh god. Okay, I'm gonna fix that in a second. But so yeah, so we have Jesus. We have this read character of lookat function that just tries to look into our lookat buffer if possible and takes the character from there. And if that one has been exceeded, it just reads a character. And oh wait, and it needs to. Oh no, we can't actually take all there. It reads a character, and we need to save that one into the new lookat buffer for the next time. No pressure. It's only 118 tests to isolate. Yeah. Oh, you should have been there like an hour ago. I was struggling so hard because there's this thing in NASM style assembly where if you have a section.data, then that's like immutable data, right? But if you have section.data colon, then that's a code section, I think. And so if you do that, then all of those are, this still works, but all of those are like in an immutable area of memory. And so if you try to write with FD, you get a segmentation fault. And that was fun to debug. I felt so stupid earlier. I'm kind of glad you teacher rated me now. Yeah, but yeah, anyway. Yeah, so we're doing read character of lookat. So we need to save the character in the next lookat buffer. Right, so we'll store that one in next lookat buffer plus its size. Yeah, exactly. and we'll increment the size. Actually, that might already work. And like the whole, I forgot to mention, the whole reason this fixed size buffer works is because we know we are only going to look at most, 5 characters. So yeah, we can just make a 10-byte character. For good measure, we can just do a 10-byte buffer. And that's going to be fine, hopefully. Right, and so, wait, that's looking, that might be wrong. Wait, if we do, wait, if we, oh god, how does that work? If we exceed our buffer and we read from things, actually no, we need to store those, I guess we need to store those in the next lookout buffer either way. Actually, I'd rather not do that here. I'd rather have the separate save character function, I think. Yeah. Also really inconsistent with char and character here. Yeah. Okay. So that one. So we read one character of look at, and then we see if this character. So if this character is an A, can we do? Actually, no, wait, not an A. If that's an O, then yeah, then it's 111. So if we have an O, then we can jump to 1. Right? Yeah. Yeah, that's where we'll see if it's a 1. And otherwise, if it's a yeah, I guess we can just do, no, we can do 2, we need T. Then set that one, we can do 2. 3, and then an F. 4, 5, 6, 7, 8, and 9. And also otherwise, I guess. I guess we don't need that jump. Okay, so if that's 1 to 11, we jump to 1. I'm just going to do a linear comparison. We could do like a binary search tree here. And let's, I guess, save like 2 or 3 comparisons, but that's just not worth it. I don't have the patience for that. So let's do, yeah, let's just do it like that. So if it's a T, we'll jump to T. And if it's an F, we'll jump to F. Keep hitting the wrong buttons. No, oh god, it's not jump, it's JE. I did that earlier already. Because jump is an unconditional jump, and then our whole comparison doesn't even do anything. Okay. S is 115. And if it's an E, it's 8. Oops. Yeah. So if it's an 8 and if it's an N, we jump to 9. Okay. Right. That's gonna be a lot of code. Jesus, that's a lot. Okay. So I guess one just needs to oh, actually, so we don't actually need a loop here, do we? Oh, we do, because we're gonna increment next time. So yeah, we'll read a character of look at, and we'll save this character immediately, I think. Yeah, and so yeah, if ix is is not an n, that's 110. It's not that, then we're gonna jump to otherwise, I guess. Yeah, right. So if it's not, so if we have O and then something, it's not an N, so like OA or whatever, then that's, yeah, we're just gonna continue, we're gonna swap buffers and continue and whatever. Yeah, I think so. I think that's correct. And then we'll do the same thing again. So if this one has passed, then that second one is an N. So we can read another character, save that one, and see if it's an E. And now, in this case, it is a 1, so we'll move, what was I using earlier? IBX, I think. Oh no, IAX. Okay, so we move IX, what's it? What will, 1, yeah. Oh, I forgot 0. There's no 0? Is there a 0? I guess 0 is not a valid digit. Oh, that's good. That would have made things complicated. Oh right, yeah, 0 can't be a digit because otherwise my code combines 2 digits by like taking the first one times 10 and adding the second one. Oh no, that's the correct. That's correct either way. Oh, I guess 0 would be fine. But one less case to consider, that's good. Right, so that's a 1, then we can skip the... Yeah, we're done. And we need to like not restore the buffer, but we need to like set the buffer to 0. I guess the lookup buffer. Yeah, because we're done. Yeah, okay. Right. So that's a 1. And if it's T, we'll do the same thing again. Remember our character. And if it's a W, what's W? 119. If it is, we'll jump to 2. And if it's an H, we'll jump to 104, and otherwise we'll jump to otherwise. Right, and 2, same thing, same character, and that needs to be an O now. So that's 111, actually, yeah. It's not 111, we jump to otherwise, and if it is, move x2 and jump to the digit loop done. Perfect, I think that should be working, and we just need to do that for every digit. Yeah, which isn't actually that bad. I mean, yeah, it's not great, but it's not the worst. Right, so it's in R. Yeah, it's not an R, we can jump, and then there's an E. But, that's not 1 E is not the code for E. 101, that's the one. And we do the same thing again. And in this case, it's 3. Right. Yeah, that's actually not the worst. Like, it's a lot of code, but it's not complicated code. Oh, actually, did I miss? No, I didn't miss those. Wait, what? I forgot the jump equal to 3. And this one's gonna convert with an O, and in that case it's gonna... no wait, if it's an O it's gonna jump to 4, and if it's an I, it's gonna jump to 5. And otherwise, yeah, let's skip that. Okay, so same thing again. It's an, oh wait, it's already an O. If it's a U, this is gonna be so amazing to debug later. Because I can guarantee you this is not correct. Like, I've made a mistake somewhere. Right, so if this is in, wait, U, and then we need an R, 114. In that case, move IX 4, jump, digit loop done. Okay, perfect. And same thing for 5. 5. Oops. Yeah, okay. 105, 118. And what I do. And then 101. Here, 546. That's 115. Wait, it's not 115, that's 105. And otherwise that's 101. Oh, that should be JE. Oh no, where did I mess that one up? Every time. That one's good. Yeah, I think it's only that one. Okay, so 6. That's 20, and chain E was 118. Yeah, okay, that's 7, and same thing for 8 and 9. Okay, oh, and 9. And then those should be all, finally. 5, 10. Oh, and I forgot the returns. So 8. It's a 7. This is impenetrable. Like, if this doesn't work, that's gonna be incredible to debug. Okay. Right. So we have our radix try. What happened to my music? Jesus Christ. Okay, sorry. Yeah. So that's alright, and we need to do otherwise. So if we haven't if we haven't found a full digit, then we need to reset our lookup buffer, or swap our buff. Actually, we need to keep. No, do we need to keep any lookup? No, we don't. We actually just need to swap our buffers. So I guess that means move objects lookup buffer, move lookup buffer, next lookup buffer. Next. Okay. Right, because we're swapping. Yeah, exchange is like really slow, right? We're not supposed to do it on, I think. Right, so we're swapping our buffers, and yeah, we have hopefully set up the size correct. And we need to reset the size. So I guess move next lookup buffer size 0. And update the size, obviously. Okay. Okay, and then once we do that, jump back to the loop. And we skip one character each time, which is good because we need to make progress. Yeah. That could technically work. We'll see if it does. No, it doesn't. Oh, Jesus. 73. Yeah, that doesn't work. Kind of figured it wouldn't. ET. Look at index. Open says not specified. That's a keyword. Another raid. Hi Meta. Thanks for the raid. When you were doing Advent of Code as well, right? What were you using today? That new one looks interesting. I'm gonna try NeoVim at some point, but I don't want to do NeoVim and x86 assembly at the same time, okay? Oh, you were doing Haskell. Oh, nice. Awesome. Hey, Dan. Oh, nice. Cool. Yeah, we got the first one. We got part 1 working, and part 2 is painful. Wait, let me just show you the code. Like, we're doing like a radix try lookup thingy. And spend most of your time learning Parsec. Oh, Parsec is cool. I mean, once you understand it anyway. Well, type doesn't go well with assembly. Yeah. Well, I mean, you need to generate the assembly somehow, right? Yeah, but yeah, I'm just fixing weird errors because okay, I'm gonna walk you through the approach now because okay, so I'm not sure how you've gotten, so I don't want to spoil you, but right, the idea is in part 1 you had like individual digits, right? There were 2 digits or like digits per line, and you only wanted like the first one and the last one, right? And alright, bye Meta. Thanks for the raid. And yeah, so the first and the last one were like digits, like ASCII digits. And now this time it's the same idea, but they're not ASCII digits, but they're like text. So like it's 1, 2, 3 or whatever. And that's, yeah, so we need to like parse the digits. Actually, that, I don't know if that's much easier in parsec than in assembly. I mean, yeah, a bit easier probably. But yeah, so our approach is like a radix try. So we compare the first character and yeah, okay. You compare the first character, and if it's an O, you know it has to be 1. Oh wait, they can be either? Oh wait, oh thanks for the heads up. Wait, seriously? Oh, okay, thanks. I would have completely messed that one up. Let me just edit to do here. Okay, so, well, but that one's gonna be pretty easy, because we just need like a... Actually, we can just add that one here if it's a number. Actually, I think I still have the code for that one. Yeah, those don't... Oh, those don't... I need to do end-of-line checking somehow differently. End-of-file checking. And otherwise, yeah, we do like this part. Yeah, that's just a comparison. If it's already a digit, we can just, yeah. If it is already a digit, we can, what can we do? Yeah, 9 is valid as well as 9, 8. Yeah, exactly. Oh wait, they can overlap. That's yeah, that's fine. That's fine. That's just, yeah, no, that's fine. Yeah, I'm prepared. I think. So yeah, we can just add a check here if ix is less than 48, or ix is greater than, or actually if it's yeah, I mean, it doesn't make much of a difference in assembly. Actually, overlap is easier, I think, slightly. But, you know. Jump to digit live, jump to digit live. If it's not a digit, actually no, we'll jump to otherwise. If it's between 48 and 57, or if it's not between those, I guess. We'll jump to otherwise. If it's not that, then this is an ASCII digit. And so I guess we'll just subtract 48 and jump to reach digit loop done. And that one should only work on the first character. Yeah, right. Because we are like, if we are looking ahead and finding a digit, then yeah, that doesn't really matter. We just skip that one. Yeah, okay. Right, so digits should work. Yeah, we need to do the end of line thing somehow. What's wrong here? Oh, that's I forgot the dot. Yeah. So I guess we can do a regex replace thing. Oh, but replace the new line as well. Okay, perfect. That's a empty space, something like that. Okay, 89. Doesn't specified. Right, that's a keyword. Invalid combination of opcodes and operands. Yeah. Okay, you need an intermediate one. That's RCX and that's IBX and that's, yeah, that should work. And BX, oops, BX, and that was from IBX. Okay. That's still not working. Why? Oh. Actually, does that work? Oh fuck. That doesn't work, because we need a pointer to a pointer. Yeah, okay, let's change that one into a buffer1, the buffer2. And those are gonna be queues. Those are just gonna be pointers to those buffers. Can I do that? Does it let me do that before I've like point to a symbol in static initialization thingy? I don't know. I guess it does. Yeah, so lookout buffer, next lookout buffer. I'm only gonna work with the values of those, not the pointers themselves. And that doesn't work. Okay, let's go RCX. That's fine. 40. Right, and look at buffer size. I also need to dereference all of those. Yeah, that's better. And then this one needs to be, this one needs to do look at buffer, the value inside look at buffer. So I guess that should work, I think. Yeah, that works. Keyword. And it's like false. Woo. Hey, I mean, at least it runs. That's progress, I guess. Okay, anything obvious, or do we need to step through? Jeez, okay. Time for GDB, exactly. Okay, so let's just, I don't know, break where does it? Oh. Let's just break on the loop, I guess. It's reading the character correctly. Wait, the first one is 6. So it should, yeah, let's think that one. Yeah, that one seems to be correct. And then 14 is 6, yeah. 14 is the first digit, and 12 is the last digit. Actually, those should just be statics, but yeah. Okay, and next one, 55. That's also a digit, right? Because that's, yeah. No, let's skip those for now. Okay, so it's not a T, it's an F, it's an S. It is an S. exactly. So it's going to be an E. Mm. 7. I guess it's 7. And yeah, so it moves 7 into X and jumps into the loop. That's good. Now this compares with how do I do that? I guess if I find a new line. Oh, actually, I think I can just jump out in the initial part. Where is it? Oh, it's part 1. That's why. Actually, I think if this one is actually I can just do the end of file handling here, hopefully. If this one is 0, I'm gonna jump to done. And if this one is 10, so new line, I'm gonna jump to what's this called? Loop done. Loop done. That probably didn't fix it. Oh. Oops. Yeah, still seg files. Yeah, I guess let's try this one. That should have wait. Yeah, that should pick up the new line correctly at least. I hope. Read digit loop done. Yeah, okay. That's perfect. So it's 7 and it's not 0. What? Why does it compare that to 0? Oh, right, because there's still those in here. No, we don't want to reset this one because we need to deal with overlap. Right, and now we do the digit thing. Right, yeah, and that should just do whatever. Yeah, and 6 seems to have worked. And 8, yeah, that's correct. Oh, so it's actually working. Where's the seg faulting? Oh, there it is. Why are you seg faulting? Move, what's that one? R6 plus RBX. I don't. Wait, what? R6 plus RBX, yeah. This one's seg faulting. So that's. Which one? The one that's swapping the buffers. Why? Oh no, the one that's trying to read from the buffer. Why? Look, buffer size should be fine. I don't think I have that one, do I? No. I do, actually, yeah. It's a non counter. Current access memory data is 6. What? Oh, I guess it's 6. Yeah, looks alright. Get index, what's that one? 0. Wait, 0? Okay. Look at buffer. Not as long, but it's a sharp counter. Current access memory. Wait, why is look at buffer 120? That should not be 120. something's gone wrong. This is lookup buffer. Oh, and this one's gonna do. Actually, shouldn't move the entire thing. Should just move a byte to AL. It's crashing again. Why are you crashing? What's going on here? Am I resetting the lookup index correctly? No, that would explain what's happening. Wait, do I only reset the lookup buffer if I haven't, oh wait, yeah, no, I need to reset the lookup buffer in multiple places. Should put that up there. That one. Okay, so we're gonna swap the buffers, reset the size, next lookup buffer size, and yeah, reset the size, and I think that might be it actually. And then we're going to look at, yeah, here we could just call that one. Call reset lookup buffers, and we're done. We also need to reset lookup buffers. Okay. Making progress. Still segfaulting. And it's still segfaulting in the same function, so presumably on the same line. Okay, so that was not the issue. I think it should still help though. I think what's wrong here? I have no idea what could be going wrong here. I guess that doesn't objects display web buffer. Let's char pointer. That shouldn't be bad. Look at buffer. What? Wait, if we print that as a long, it's 110. That's weird, what? So buffer 1 is some pointer. I guess, wait, no, I guess 1, 0? Yeah. Assembly, yeah. Yeah, we're doing 86 assembly, and I'm kind of struggling with buffers and things. And something's going wrong. Oh, that's not sure it's print. Okay, I guess that's not That doesn't work. What if I initialize this and start? Yeah. Move keyword. And it's still segfaults at exactly the same position. Great. I guess I will display this as a void pointer actually. Okay, so that's the lookup buffer. And also next lookup buffer. Yeah, those are one apart. That seems wrong. There shouldn't be one apart. This one is, wait, what? This one's 10 bytes. This one's, oh no, it's not 10. It's not 10 bytes. It's 1 byte with the value 10. Oh no. And still segfaulting though. Okay. So those are unchaining. Yeah, that works. And they're far enough apart now. Hang off. Thanks. Better. Yeah. Okay, so this works. And now if I the breakpoint, or go to the, yeah, that's a breakpoint. Wait, did I set a breakpoint? I guess. Oh, it already sets breakpoint and everything. Then it crashes because look at the 6e for some reason. Why? What's happening? Okay. Let's try that one again. Oh, and their next lookup buffer has been corrupted. Okay. What's that happening? Between S and 7. So somewhere between this and this code. So probably in one of those two. Either read character is look at or save character. So I guess I'm just gonna break those. Save character seems fine. Oh, wait, fuck, I missed it. Yeah, started as. So it's save character, apparently. Okay, not before the S. So I guess wait, it's happening. It might not be read character so good. Wait, it's save character. Scroll up. Do that, can I? No, I can only scroll in there. Okay, so I don't know. I don't know what's happening. I guess I'm also gonna break on the read digit loop. Yeah. Something between those two. So it's save character. Next look at buffer. Value that it's moving regs into that. Oh, do I not? Oh wait. Oh no. Oh, I know what's happening. That's the one. Next look at buffer, but that's a pointer, so I need to dereference that and move into RBX. Okay, that's the one. And it's kind of working. Okay, it's not self-voting anymore. That's an improvement. Okay, so it's 77. That's... Wait, that's correct? No, that's not correct. No. Well, actually, that one kind of should have broken some stuff. So it's 6, 7. That's the first one. That's correct, at least. So I guess... I guess let's see if the digits are correct. Wait, where does that reach? It's an RAX. Yeah. Yeah, so we can look at RX, that one's correct, and if we set all this call, that shouldn't modify RX. Yeah. Okay, so that's working. Then the next one. It's 7, that's good. There's only digits, those should just work. 9. Then it's an 8, yeah. And then oops, skipped one. Oh, that's wrong. That's very wrong. I don't know what happened there. Let's just restart. 6, 7, 9, 9. Immediately 9. Yeah. 6, 7, 9, 8. And then 115. Okay, something's wrong. 7 didn't work correctly. So it didn't pass 7. Why did you not pass 7 correctly? Does it get to that one? Oh yeah, it does. Wait. What? It's 7, so it does reach 7. Really? Oh, yeah. It does reach 7, and then press one character, there's another character, one more. Then just 7. and that's perfectly correct. What? And that's the next one already. Wait, what's this one? 10 is a character. It's an N. It's an N? Uh-oh. It's not skipping the N correctly somehow? 7. No, I'm setting that one. Why are you not saying the N correctly? Wait, oh, why is it? Shouldn't it start at the E? I think it should. After the 7. Zero. What's 0? That's very wrong. Okay, I don't know what's happening. Okay, so let's have a break on the digital done. Then run the program actually. The first one's gonna be 6. Then 7, 9, 8, 100. Oh, that's S. 7. Yeah, that's correct. And then the next one is Horace. Then it goes into loop done. Yeah, that's correct. No, that's working. Am I mutating R13 somewhere? No. If you shouldn't do that, I should just add an accumulator here. Okay, that's better. R13 is 6, 7. That's perfect. Yeah, that's actually what the first line is. And the next one is a 6 again. That's correct. And then an 8. Yeah, it's working so far. And then a 3. Yes, it's working. I don't know what's on. That's 2. This one should be a 7. One's backtracking a lot. 7. First one was a 6, and current one was a 2, yeah. Oh no, it's a 7, yeah, that's working. And it exits what? It read the 7, and I guess 5. And then exited. Why? 7, 6, yeah. 6, and then 7, and then somewhere here it just stopped. Just wanted to done. Like it read an end of file. Oh, no. What? Why? The buffer might be too small. I don't think so, because I'm refilling the buffer, right? Like, the lookat buffer is just needs to be up to 5 characters technically. I'm using 10 already, because I don't want to get off by 1 errors. But like that one's only for one digit, right? And 1 digit can never be longer than like 5 characters. And the actual input buffer is getting refilled automatically. That's what read char does. So I don't know what's happening. Like somehow this is reading an ender file. Right, so read char is returning 0. And where am I doing the ender file thing? With the comment. Oh. Okay. Here. If that reads a 0, while trying to read a digit, it jumps to done. Yeah, that's fine. Okay, let's rerun this. I know where it's going wrong now, so 12, 6, 7, 9, 8, 7, 6, 8, 8? Oh yeah, 8. 3, 2, and now there's a no, that's not one yet. It's an S, and it's at S. Otherwise, wait, why did it jump to otherwise from S? That seems wrong. Oh no, that's the previous S. We have quite a few S's before that. Yes, 7. So it's SE, yeah, so it reads that it's 7. And reads that from correctly, and now it's in loop done. Okay, so just to, yeah, so it's loop done. So it calls reset lookout buffers, but that's fine. It's not setting a 14 because it has been set already. It is setting a 12, yeah, correct. It's jumping back. And it reads a 0. Why is that a 0? Why does it read a 0? That's... Oh, maybe it's resetting the size incorrectly somehow? Like it's almost certainly the lookout buffer somehow. Yeah. Maybe it's, wait, what's the one, what's it called? So it's lookout buffer size. That one is 4. Yeah, that's what it should be, I think. Now I said char 4. Buffer is 320. What? No, that's not. Wait, what? Where's it? Only an N. Am I moving like too much somewhere? Am I not moving in byte increments? Maybe? Oops, no, that's fine. I'm just swapping, setting the size correctly. It's an N, that's D. Wait, what if I put like, what do I do like, S7? Is it gonna be able to do with that one? Yeah. Oh, now it immediately exits. Why? Why would it do that? Okay, break. Save character. Wait, it's an S, otherwise reset lookup buffers. Wait, why is that going to reset? Yeah, no, it's supposed to reset them, I think. So, I guess look at buffer size should just be 0. Oh, it's still, right, at this point it's still next look at buffer size. Yeah, that one's 1, that's good. And if I dereference the buffer, one is 0, that's bad. Why are you 0? Blood thickness, yeah, seriously. Hello, Kasha. Yeah, so we're doing advent of code in assembly, and there's something wrong with my buffers. I don't know what's happening. Like there's somehow a 0 sneaking into the buffer, and I have no idea where that one's coming from. I mean, it has to be safe character, right? But that one's like, it's not complicated. Oh, it's this one. Yeah, it's this one. Found it. It needs to move 1 byte at a time, not an entire word. Well, that was quick. And it didn't print anything. Wait, what? I mean, it is, like, you know, there's a lot of code for matching on text in here. Because I am slowly losing my mind. Like, this is actually pretty complicated for day 1, honestly. Like I did last year's in assembly as well, and that one was quite a bit easier. I don't know. Do you have a function to print out characters as if this now? Actually I do. I just need to make sure that doesn't break anything. That's the thing. That's why I'm using GDB for everything. Like, print debugging in assembly really doesn't work that way, because like as soon as you have even as you do a syscall, you like mutate some registers, and so it's not very helpful if you're debugging. But I guess I can try that. So I guess in like per line, I can. Wait, what am I doing here? 14. Oh wait, loop down. That's the one. Yeah, I guess I can move AX, I think it is, and print number. I think it's returning 0 though, because there's no, like, it's not printing anything, and my function doesn't actually Doesn't actually print anything if it's 0, because I haven't needed that one yet. Oh, I guess I can push and pop the values. Yeah, I guess I could try that. Oh, it's not printing anything. That's strange. Is it not printing anything? Or is it, oh, it's printing 0. Yeah, so it's 0. How is that 0? What? Okay. Okay, so it's returning 0 somehow. How? Okay. Let's break on. Let's actually, what's that? Recompile. Let's break on read digit loop done. And wait, I'm not. What am I doing? Okay, so right, our AX is 7, so the first digit is 7. That one is correct. I guess we can just step through until something weird happens. Yeah. So our 14 is 7. Wait, our 14 is 7? Oh yeah, our 14. Wait, no. What's our 14? Oh, the first digit. Yeah. This one's 7 and our 12 is 7. Because, yeah, it has to be. And it exits. Oh, I guess if it finds a new line, it exits and doesn't continue the current one, but that's fine because there is a trailing new line down here. So it's fine if it doesn't like continue processing the current line if it finds a new line. But where's the 0 coming from? Okay, is that again the buffer? I guess. Yeah, I guess let's run that one again and display. Well, I guess let's break on reset lookup buffers. And now let's display. Actually, it's focus first. Let's display size. Actually, next lookup for size is actually both. Why not? And then can GDB do this? No, it doesn't. Okay. Let's do 5. Ooh. Why is that printing like that? It's weird. Oh, that's not okay. Okay, I don't know what that's doing. I don't remember how to do fixes array things in GB. I guess we can just print that as a chop on. Yeah, that works. And lookup buffer size was 1, right? Yeah, that's good. That 1 plus 1 is empty string. Okay, so there's a 0. Where's that 0 coming from? I guess we're not swapping buffers correctly somewhere, maybe? Wait, where's reset lookup buffer being called? Otherwise. Wait, is it being called from otherwise? Is there like a back... Oh yeah, there's a backtrace. Digit loop done. Okay. So it's not being called from otherwise, it's being called with the finished digits. So one was S and one was 7. So that one wasn't saved correctly, I guess? Why? That's strange. Yeah. I don't know, let's break on. I don't even know what to break on, honestly. Wait, let's just restart. Okay, let's break on. I don't know, let's but let's first display just look at buffer and also play long look at buffer size. And this will be long next look at buffer size. Okay. Okay, so that's empty. That's correct. Guess we can just go like step through that. So it's 0, 0. Now we're reading one character and we're saving it. So next look at buffer has an S. That's correct. That's perfect so far. Those are being swapped because the S didn't have anything. Yeah, that's also good. So we are reading an E, and that's 1. Good. And now there's an N. What? 7. And it has been overridden. For the save character. Next look at buffer. Size. Wait. What? Oh, I'm such an idiot. I haven't actually used the size at all. Ah, okay. Yeah, that explains a lot. Okay. Back on track. I guess that hopefully helps. And it outputs something. Okay. Let's check if that's correct. God, that would be so amazing if that's correct. Yeah, don't celebrate too early. I'm not that confident. And no, it's not. Told you. Team. And it's not correct. Okay. Yeah, it seemed a bit small, maybe. Okay, so what's going on? Well, that's fun to debug now. Let's try something smaller. Because it's really a lot. Maybe this. 144, is that correct? That's 7. Actually, no, wait, this one doesn't even. Oh, wait, did I keep the 7 in there? That would explain what's wrong. So I guess it's 48,206, maybe? That's not the right answer. It's too low. Okay. So we're losing something somewhere. And that's kind of what I expected. Okay, so let's try something smaller. Let's try maybe this. Sure. Does that one return 210? What's that? That's 6, 7 plus. Actually, should enter that immediately. 6, 7 plus 6, 5 plus 5, 4 plus 8, 4. 270. What's it returning? 210. Okay, so this one's wrong already. Maybe I can cut out a few more. That's which one? That's 6, 7 plus 6, 5. 132. Yeah, that one's off by 1. Interestingly. I wonder where that is. Oh, wait, if I add a new line, it's 134. Oh no. Oh, God. Okay, no, that one makes sense. So the first one's correct, it's 67, and the second one should be 65 on top of that, but it's not. Yeah, it's actually 67. Yeah, it doesn't pass the 5 somehow, I guess. Right, if I just do this one. Yeah, 67, it doesn't pass the 5. So I guess it's probably skipping a character somewhere. That's my guess, anyway. Yeah. Okay. Right, next lookup buffers IX, yeah, for 6. Yeah, so that's 6, and then that's gonna pass a, what's it gonna pass? It's gonna be an 8, yeah, and then that's gonna be a 3, a 2, and a 7. Eventually. Yeah, 7. Okay, and now there's a D. Wait, one has been reset, which had a D. And that's even. Yeah. Oh, I feel stupid looking at this as well. Don't worry. X/VX, that's the one, thanks. That's the one I used before. That helps. Yeah, thanks. Yeah, actually, but I think just looking at this string is a bit easier in this case. But okay, so there's wait, we have 7, and we have a D and an even. Hello. Yeah, I've almost only used GDB for assembly. I've actually almost never used it for C. But yeah, that's somehow it's not passing the 5 correctly here, and I have no idea why. X4DC is the actual characters. Nice, thanks. That's useful. Even, yeah. Okay, so it was at 7. That's even as like the next characters. Oh, it's swapping. Wait, it's swapping the. Wait, is it skipping the buffers or something? Structured logging frameworks for assembly. I guess not. Wait, it's resetting the buffers somehow without like. Oh, I know what's happening. Okay, I know what's happening. Okay, if there is, I guess I need to do that in reset. Look at buffers. Yeah. Okay. So if one thing is, if we have one buffer that's like that still has like even in it, right? And then we pass one character, and we know it's wrong, right? Then we can't just reset them. I guess we need to like copy over VEN at least. Actually, I think we also need to copy over VE to our other buffer. Hey, Cherry, you got it? Awesome. Nice. Thanks for watching. Yeah, I'm really struggling right now. I've always got it. Okay, so I guess if the size of the current lookup buffer is larger than the next one, we need to copy over all the remaining elements. Or do we? Yeah. No, if we no, actually it's not the size. If we have like once we haven't exhausted yet. Yeah. So copy over the remaining elements, I guess. So yeah, I guess. I guess we'll yeah, actually we'll just copy things over until we've got the until the length matches up. Oh hey. Hello. We're doing Advent of Code and Assembly, as you've probably seen, and I've been streaming for almost 4 hours now. And most of that has been Patchu, because Patchu is awful. Which Arch? What do you mean, like Arch Linux, or what do you mean Arch? Or do you mean x86? Yeah, it's x86 assembly, because that's what I have. Oh, right. Yeah, I'm on x86, so that's easier to run. Yeah, and also it's the only one I know, so that helps. But yeah, Jesus, like, if you look at the code, it's like 379 lines of assembly, and there's like a radix try in there, pretty much, because we need to match on like character words, and so it's, you can do like a try where you like compare the first character, and then depending on that, compare the remaining ones. Yeah, it's really breaking my brain right now. But we've almost got it. There's just something wrong with like the look ahead buffer thingies. Where like if you have something like S7, that's the one I had earlier, then it reads an S, might interpret the rest as 7. Or actually, wait, better example is probably like F1, where it reads the F, so that might be 4 or 5. And then it reads an O, so that might be 4. But then it's neither, because it's an N, so it needs to backtrack and like restore the O. And so like the way I'm doing that is with where you have like 2 buffers, to look at buffers, and you like remember every character in one buffer, and then if there's anything still in the other one, you don't read a character from the input stream, but you take that one, and then like once you're done, you swap them over. And yeah, when swapping over, you also need to carry over some characters, and that's what I'm fixing right now, hopefully. Yeah. ARM32. Yeah, I've heard nice things about ARM32. I've just you know, always use x86. You just reset the counter and move one character ahead. You couldn't because wait, move one character ahead. No, you couldn't because I guess you could if you put like the entire line in one buffer. Then that would work. I don't have the full input, but like the issue is the input. Like there's a second buffer for like I'm reading the input character by character. That's the idea. So there's like a second buffer for those, and you can't really backtrack in that one. I guess I could have done like one. I could have like saved the entire line in one buffer, but oh no, actually I couldn't. Because the issue is I don't want to do dynamic memory allocation because I don't want to mess with mmap or anything. Because I'm not using libc. So I would need to know the size ahead of time. I guess I could just do like 1,000 and it would probably be fine, but yeah. Yeah, it's almost working, I think. I said that like an hour ago already, but you know. Okay, so I guess if next look at buffer size. Oh, whoops. If there are still characters remaining, so if our what's the index thingy? Look at index. So I guess so if the look at index is larger or equal, I think, yeah, then we'll stop. Yeah, right, if we've exhausted our buffer, then we'll just jump out. And otherwise, we are gonna, I guess we can just use our existing functions. I guess read character of look at and then set character. Yeah. I think that's gonna increment and decrement things correctly, hopefully. That printed out something with 600. Wait, 662. Oh, that's way too high. It should be 65. Wait, how does it. How did that even happen? 662. Oh god, that's completely wrong. But like, that's like impossibly wrong. Because there's. What? It can't be 3 digits. There's only one line. Oh no. Oh no. I've broken something. Like, okay, I did Advent of Code in assembly last year, and that one was so much easier. Jesus Christ. Okay, okay, where do I even begin? I guess, yeah, let's do redigit loop done again. Right, so that's reading 6, that's correct. And that's reading a 3. Yeah, did it skip the 8? Oh no, missed that one. Reading the 2. S, S, should be one more S. 7, 7, okay, so it's reading the 7 correctly. Oh, R14 is wrong. Why is R14 56? And wait, why is R12 102 now? What? That's completely wrong. Why? What was 7? Oh, does that one mutate something that's not supposed to know? Which one mutates RBX? I guess I'm using RBX, right? Am I? No, I'm not. No, I'm not using RBX. Well, that's an issue. Oh, and also I'm mutating that one anyway. So I guess... Even an F is in the buffer. Is it? Yeah, it is. No, that's good. Yeah, it should be. No, it shouldn't. Wait, no. Why is the F in the buffer? F should not be part of that. Oh, also, no, I'm doing it. I guess I'm just gonna copy those manually. Yeah, I think I need to reset the index. Yeah. No, wait. Oh, no. Oh, that's awful. Oh god. So I need to move the old buffer and need to move the next buffer over. No, I don't. No, I don't. So if I have like 7f, if it's that one, then I have like E, V, E, F in my buffer, or E, V, E. I guess I have like 5, I have like S5, then I have well, it doesn't really happen, but you know, sake of argument, I have like 5 in my buffer. Oh god, my music is messing up. Wait, if I have like 5, then what's happening? 5 is in my buffer, and so I'm going to or 5x, and then I'm doing like 5, and then x is left over, and the next one needs to be like the remaining ones, and then x. No, like, wait, what? No, this should be copied over implicitly, because I'm reading one character from the buffer, and then the next one, next lookout buffer. Oh, I guess this isn't actually doing anything because I'm overriding the next. No, I'm not. No, this should have been saved into the. No. This should work. Just calling like read character with lookout and things here. And save character should work. Oh, am I jumping to the loop? Segmentation forward. Woo. Well, your characters look ahead. Moving, it's reading. The buffer would look at index. Okay, this is so complicated. Okay, so I guess, you know what, let's check that all the characters are being returned correctly. I guess, let's put a debug thingy there. Hello. Wait, why can't I can't switch background. Okay, weird. Yeah, let's try that one. Alright, so let's check that the characters are being returned correctly. That's wrong. What? Oh, I didn't set the background correctly, I guess. Implementing a state machine. No, I'm kind of. I mean, I guess a try is a sort of degenerate state machine. I'm doing a try, or like basically a radix try. So I mean, I guess in a way it's a state machine in this case. So like the idea is you have like words 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And so you, if you want to match against those, you can match against the like one character at a time. And if it's an O, you know it can only be either 1 or invalid. And if it's T, it can be 2 or 3. And if it's F, it can be 4 or 5, or and so on. Yeah, so you're matching one character at a time and then just checking that the results hold. But that's the easy part. That part works, I think. The difficult part is actually backtracking. Because if you have something like, say, F1, it's an F, so you're here. And then there's an O, so you're here. And then those don't hold. So you need to backtrack and try 1 again. Right? And you can't just skip the O, because like, then you're skipping 1. And that's why I have like 2 buffers, and one look ahead and one like, look at next time. And I'm swapping those, and something's going wrong, and something's being copied incorrectly, and I don't even know what's happening. Wait, why is my debug not working? Why is my debug label not working? What am I doing wrong? What's that? Like, this weird. I don't know. Breakpoint. Perfect suited. Yeah, that's fine. Oh, actually, yeah, I also need to care about that one. So I'm gonna do... Yeah, so that's a 3. That's not the first one, definitely not. Oh, I guess I'm in reach channel, yeah, okay. Next. Reach out. Why am I not skipping through reach out? I don't wanna... oh. Okay, something's wrong. Something's very wrong. Okay. But why am I freaking reach out? What's wrong with GDB? Actually, let me just do a second debug one. Make Patrol S82. Ah, nice. Yeah, but I don't know if I somehow debug is weird. Maybe that's like a reserved word or something. But if I call it debug one, it works. So I don't know. Okay. Debug. Okay, so the first one's an S. That's correct. Next one is why is it stepping into digit loop? I didn't set a breakpoint there. Oh, because I did NI. Whoops. But it's still stepping into that one. Here. I. It's good. X. Perfect. Okay, digit loop done. So this one should be an I now. And it's not. It's an 8. That's an issue. Okay, so it's not actually... okay, so it's not actually using the buffer, if it's correct, at least. Let's think about what's happening here. So, yeah, this one jumps into redigit loop done from somewhere inside of those. Then it's not actually resetting the buffers correctly. I guess it doesn't really do much other than reset look at buffers, at least nothing that touches the buffers. So I guess this has to be wrong somehow. Okay. Yeah, so what's it doing? So look at buffer should be empty, and next look at buffer. That's wrong. That should be look at buffer size. Is that the issue? I don't think that's the issue. But okay, so next look at buffer is should be IX, right? And current one should be nothing. And then what? It's doing IX, and yeah, it should try to copy over all the remaining ones in current, but there are none, so it doesn't matter. And so it just takes IX and continues and returns I. It just swaps those two. So that one to nothing, this one to IX, and then yeah, Yeah, the next one should return an I. God, I need to do GDB init. I'm going insane if I need to type that one more time. Okay. That works, right? Yeah, perfect. Okay. Wait, it's returning 64. 4? Where's that 4 coming from? There isn't even anything resembling 4 there. Alright, see you too. Bye. Oh wait, I have a new line in here that might break something. 67. Okay. 4 is half of 8. I mean, yeah. You're not wrong. I actually have no idea why it's like completely breaking when there's an. Oh, actually, no, I know what's happening. No, I know what's happening. If there's an empty line, it's subtracts 1 because I'm using -1 as my sentinel value if there's like if I haven't found a first digit yet. Gute Nacht, Eckhart. Yeah. I don't know. It's not parsing the 5 correctly somehow. Okay. So let's try that one again. Let's break on debug 1 and debug 2. Guess I should copy those in here as well. Can't copy from JDB. Oh, that's annoying. So that's an S. That's good. Wait, yeah. Okay, so S, that's good. And should be wait, X? Oh, wait, did I miss the I? I guess I missed the. No, I didn't. What? Let's restart. There's an S. Oh, and then there's an I. Yes, debug 2, that's correct. And now there's an X. Yes. And now the next one is a 6. What? Oh, I guess that's. No, what? Is it the wrong one? Oh no, that's. No, it's working. It's working. That's an I. Okay. So there's an I. That's just in the wrong function. Next one should be an X. Yes. The next one should be an. That should have been an X. Yeah, that should have been an X. Isn't it overcomplicating things? It would simply have some number 1 and number 2 as sort of a pointer to the start of the string and turns into the. Yeah, that doesn't work. Yeah, thing is, that one doesn't work. At least it doesn't work in general, because I want to do this without dynamic memory allocation, because that's annoying. And so I need to know that I can't just have a pointer to the string. I'm streaming characters. So it's also, yeah, so like I could technically have one array per line, I guess. But then I don't know in advance how large that one's gonna be. I could just make like a 1000 element array, I guess. But that's cheating. And so yeah, I'm doing like proper buffers and actually doing this in constant memory usage. So yeah. And also, I mean, I've said this like 2 hours ago, but I'm almost done. It's almost working. I just think this 8 is wrong. It should have been another X, I'm pretty sure, but I'm just gonna step through. Because that one's not gonna cause any issues, at least. It's a B. There's a 3. There's a 2, that's correct. C should just be ignored. Yeah, and then there's an S. Another S, yes. And then there's a C, yes. D, G, J, S, and now, yeah, plus 7. And now it should start with an E again. Yeah, okay, that's good. Oh, but it's EN, it's not E. It skipped the VE somehow. What? Skip the VE. Oh, I guess it's if otherwise resets the buffer. Yeah, that's what copy loop is supposed to do. Let's add another debug. So if there is any copying going on. Did it take the 7 properly but then went over the even again? Well, it's supposed to go over the even again, because numbers can overlap. You can have like one, wait, 7, 9. You can have that. That's allowed. That's 7 and 9. Would still be constant memory if you stream it and signify as a rolling window on the whole string. But isn't that what I'm doing? Pretty much. Oh wait, I guess I have to do this thing again. Part of the string advance until the point where I look at number and set number 1. Determine part which is set number 2 to the number and counting a new line, and the sum which is set number just starting again. Wait, what? So you're so you're like, you have one pointer here, and you're advancing one over the string is what you're saying. And like once you find 6, then what? You need to backtrack still, right? So like if you have 7, 9, like you still need to start from the beginning again. Right? And even if you see that as a rolling window, like you still need to keep those characters around somehow. Right? And so you can do what I'm doing and just like remember them in a buffer. Or you could keep the entire string in memory and just remember a pointer. But yeah, that one's not constant memory. What did I wrong? What did I do wrong? Reset. Oh, that's reset lookup buffers. Ah, that's fine. Does this mean that it would end up with 7 and 9? Yeah, it does apparently. That's what someone else told me recently, or just now. Guess I'm gonna. Wait, yeah. 2, 3, 4, 6, 7. That's gonna. 2, 9, 8, 2, 3. Yeah. What else? Wait, actually. So they have a bunch of overlap in the examples. Actually, they don't show that there, but yeah, apparently that's overlap is allowed like that. So what's wrong? Should look at buffers dot debug 3. Oh, I spelled look at. That's why. Okay, so there's an S, that's good. There's an I, that's good. There's an X, yes. And now that should, wait, yeah, there's an I, that's good. Now there's another, oh, there's an I in the copy buffer thingy. Yeah, itself calls, wait, what? 3? Oh no, I was the last one, right? And that one returns an X, yeah, and copies that one over. I think that's correct. It's an X. And now it returns an 8. That one should return an X again. Yeah, that one should return an X. Why doesn't that one return an X? Actually, let me display my buffers as well. Perfect match that returns a simpler boolean if location A matches location B. Then I have compared the codes to match and advanced until the compared string runs out. Location A matches location B. Compare the codes to match and advance until the compared string runs out. But still, how are you backtracking? Like, how are you, if you have 7, 9, how do you backtrack after you hit 7? How do you get the old characters back? I guess, actually, you know what? One could do kind of like a depth first search kind of thing, where you do like, where you try, if you hit an E, you try like 7, or you try something that starts with an E. So you could also try 8 here. And you do like all of them recursively. Yeah, I'm not going to do that in assembly, but that might work. I guess if you're using a high-level language, it's so much easier anyway. You know, I'm kind of thinking of just doing this one in Haskell when I'm done, because that's gonna be like almost a one-liner. I mean, I think you could do that as a one-liner. Time to implement the state machine for some regex. Yeah. Oh god. And I genuinely don't know what's going on here. Okay, so buffer has an I, yeah, that's correct, and it has an X. And now they've both been copied over, it's good. Now there's an X in the locate buffer, right, because it just looked at I. Now X is being copied over. Is that what should do? Probably. But thanks. 4 hours of assembly. That's fun. And then it's 2. There's another. Wait, what? There's another X. What is just swapping between X and X all the time? Wait, what? What's happening here? Why is my buffer not being filled at all? Did I mess up the size somehow? No. That looks fine. Right, let's restart that one. So there's... Wait, what's it doing? It's returning an I. Yes, because I skipped this. Oops. And not saving that from the buffer. Oh, I guess it's not saving anything in the buffer until the S at least. Yeah, maybe 3, 2. Yeah, now the S is being stored in the next lookup buffer. Right, that's correct. And the current one is empty. Now let's look at that one. Setting an S, starting the next one in the lookup buffer. Actually, not even doing that. D. And the look ahead, right, because it's after an S. Now this one's reading. Wait, that's it. Why is it a G? Shouldn't it have read the D again? I don't know. It's an S. E. That one should end up in the buffer. Yes, it does. E should end up in the buffer. Yes. Let's simply find 7 and set number 1 equals 7. Advanced state and then find 9 and set number 2 equals 9. No, okay. Yeah, oh, nice, you mean, yeah, that's what I'm doing, basically, but, that doesn't, you still need to backtrack. You can't pass one, I guess you can do the kind of recursive thing I mentioned, although that's technically not constant time. I guess, yeah, maybe on some inputs, constant space, but yeah, the issue is how do you advance the state? Like if you find, oh, I guess no, you need, yeah, that's pretty much what I'm doing. If you need, yeah, if you can advance the state and like look ahead, you need a buffer in between, right? Like if you can't find 7, wait, here's 7, 9, and like you're here, right? And now you read one character, you read an S. Then yeah, if you find 7, you need to still somehow iterate through this thing. You can either like consume this one at a time until you find 7, and then you need to backtrack, and then you need to try even 9 again because you've consumed the n, or you need to keep the string in memory and like index into it and compare 7. That's an n, so now you can like skip the first one, right? But you need like a buffer in between either way. You can't just stream one character at a time through it. Okay, so what's happening? EV? Right, it gets EVE, it gets even. And now what? Ooh, now it got the 7, so it moved the lookup buffer over. And the next lookup buffer is still empty. Yeah, as it should be. So now there's an F. technically. Wait, no, there's not many. Oh wait, no, it's going through even again. E? N. Wait, what? No, it skipped VE. Why did you skip VE? Oh, I guess, wait, what's, oh, I'm probably not incrementing the index correctly. Right? Or resetting that incorrectly, more likely. Okay, attempt number, I don't even know. Yeah, that looks fine so far. Oh no. It swapped buffers but didn't reset the index. Why not? Oh, I guess I'm just not resetting that one. 809. Thanks. You're gonna get this at some point. Yeah. Actually, 64. Oh wait, that's correct. No, that's not correct. 67. Wait, why is this -3? Yeah. -3? I can understand why it would be -2, because it's like not seeing any characters and maybe treating that as start and end. But I don't know. It's 67. It's still not seeing the 5. Why are you not seeing the 5? Yeah. Okay. Right, I can skip through the first ones. Yes. Where do you move the character out of the input string? I would never change the input. No, I don't have an input string. This is the thing. I'm reading, like, effectively, well, I'm not reading character by character from the file, but I'm reading, like, there's a buffer in between, but it's still effectively character by character. I don't have the entire string in memory. Right? Because that would need dynamic memory allocation if I wanted to allow arbitrary lengths of strings. So I can't decrement the pointer. Like what's before the pointer doesn't exist anymore. And I don't even just have a pointer into the thing, I just have the character. So there's an S. Wait, where am I? D, okay. That's then even. Then that's in the lookat buffer. Lookat index of 1, 2. V, wait, that's correct. Wait, wasn't that failing earlier? Is I fixed that one? E. N, wait, this is perfect. Okay, this part is working. I think. Now Vn is in the next lookup buffer. Yes. Lookup index is 4, and now Vn is the next one, and lookup index is 0. Yes. It's keeping En around. Yes, and there's an N. Okay, I know why is that 5 not working? There's an F and a lookup buffer of 1. What? Oh, it's just an F. And then there's an I. V. That's working so far. And then there's an I again. What? Where did that... No, I guess it's... Oh wait, am I... Did I just make a mistake here? Wait, 5 is 1 of 5. Wait, let me just... What? From... Oops. Every time. So there's an F. That one's being jumped. Wait, so 1 or 2, that's F. And then 1 of 5 is jumping to 5, that's correct. And then 118 and 101. No, that's correct. Damn it. ASCII, seriously, yeah. And simply allocate 10 characters on the stack and even eliminate more for a single number. Yeah, that's what I'm doing. Like, I'm not allocating on the stack, I'm allocating in this buffer here. But like, I still need to like, shift that one over. Okay, man, so that one's working. That would have been so much easier if I just messed up the ASCII code somewhere. Yeah, I guess I didn't. Then I have no idea what's going wrong here. Where did that I come from? Where did that come from? Seriously. I guess I'm just gonna remove all of this because I don't really need any of that. Like if I just run this, yeah, it's 7-7 because it just takes this one as the first and last digit. Which is fine because they're always like 2 digits per line. So it's somewhat even building up in the buffer. Okay. That's going to E, E, N, and now it's going through V, E, N. Okay, so far so good. That should be E, N. And now just N. Yeah. Okay. And now, oh, that's being passed as a 9. Okay. Oh, that's why. Because there's an N and then there's a 9, and that's why 7-5 is an issue. Let's pass an N and then F. And there's one N in the lookup buffer. Wait, no, no. But there's an F in the lookup buffer now. That's all, yeah. Okay, so that's not the one. So now it's getting an F. And now it's getting an I. And yeah, because lookup buffer has been exhausted. So there's an I, and so lookup buffer is empty. So it should pass a V next. Yeah, and it does. And the lookup buffer is 1. Yeah, that's the I. And now 5. Otherwise, wait, it's not. Wait, it is the V. Something about the V is wrong. It is an ASCII here. Why? 5V. 118. Heh? What? What? Okay, so it passed a V. And there's a V in RAX, and this one jumped to otherwise. Why? Why would it do that? What? I'm so confused. Hello. I'm not checking for I twice. Wait, where am I checking for I twice? I'm not sure what you mean. Oh, you mean... Oh, I am! Oh my god, thank you so much. Oh my god, that's the issue. Oh, that's the one. I'm checking for I twice. Yeah, 75. Oh my god, thank you so much. Okay, let's try the full input and just hope this works. Told you I was gonna make a mistake there. 55,343. Not sure whether it's not printing a new line anymore. Actually, I had code for that. And, here's moment of truth. Let's move that all. And that's the right answer. Woo! Finally. It's working. Okay, 4 hours 36. 4 hours 36 minutes for day one of Advent of Code. Jesus Christ. Okay, that was fun. Actually, I don't think that would be that easy even. Hey, hi Meta! I did it! It's working! Wait, I can show you some of the code. It came out as 389 lines of assembly. But there was the last issue I had was just I was checking for the I in 5 twice. So it was looking for FIIV. And it's finally working now. I'm free. Okay, perfect. Let's see if there's someone I can raid, I guess.